Hey guys, I'm Venkat, and in this course, we'll cover all the basics of SQL. This course is for anyone who wants to learn the basics of SQL. Software engineers, quality engineers, business analysts, data analysts, support engineers, anyone really who wants to learn the basics of SQL. Now, to follow along with this course, you need to install two softwares, SQL Server Database Engine and Management Studio. Both these softwares are free to download and install. I'll walk you through the steps shortly. Once we have the required softwares installed, we'll start from the very basics. How to create, alter, and delete databases, database tables, create relationships and constraints like default constraint, check constraint, unique constraint, referential integrity, primary key, and foreign key. We'll then discuss everything you need to know about SQL Select, Group By, different types of joins, including advanced joins, union and union all, finally, store procedures with and without parameters, return values, and their advantages. I hope you'll find this course useful. So let's get started. In this video, we'll download and install the latest free version of SQL Server. As of this recording, the latest version is SQL Server 2019. Now, these are the four different editions we have in SQL Server 2019. Both the Enterprise and the Standard editions are for production use, so obviously they have license costs. The Enterprise edition has got more features than any other edition in SQL Server 2019 and obviously the most expensive. Both these editions, that is Express and Developer, are free to download and install. The Express edition has a size limit of 10 GB. That is, you can only use it to build small data-driven web and mobile applications up to 10 GB in size. The Developer edition, on the other hand, has all the features of the Enterprise edition. It's also free, but you can only use it for non-production use. So if you are learning SQL Server, then this is the edition that you want to download and install. Now, fire up your favorite browser and then search the internet with this search string, download SQL Server. You should see this Microsoft SQL Server downloads page. Click on that. And then when we scroll down a bit, you should see the Developer Edition. This is free to download and install, so click Download Now button. Double click on the downloaded executable, and if you get any security prompt, click Yes. On this screen, you have to select the installation type. Basic installation works for us, so let's select that, accept license terms, and then click the Install button. The installer automatically downloads and installs SQL Server. How long the process takes obviously depends on the speed of your internet connection. There we go, installation complete. And what we have just installed is SQL Server Database Engine. Now we need another piece of software called SQL Server Management Studio. And to install SQL Server Management Studio, click this button, Install SSMS. SSMS, by the way, stands for SQL Server Management Studio. When I click that, it again takes us to the Microsoft Downloads page. And when we scroll down a bit, here we have the link to download SQL Server Management Studio. So click on that. There we go, download complete. Double click on the executable to install. Click yes on any security prompts, and then finally click install button. There we go, SQL Server Management Studio is also successfully installed. Finally, close this SQL Server installer window. Now, click on the Start button and you must find SQL Server Management Studio under Recently Added tab. If you don't find it here, scroll down in the Programs list, and then within letter M, you'll find Microsoft SQL Server Tools, and in this folder, we have Microsoft SQL Server Management Studio. Click on that to launch. We want to connect to SQL Server Database Engine, so select that from the drop-down list, and then the server name is the same as our computer name. If you don't know your computer name, click on the Start button and then search for this app, System Information. You can find the system name right here. So the server name is the system name, and then we want to use Windows authentication to connect to SQL Server. So select that from the authentication drop-down list and then click connect. There we go. We are now connected to SQL Server Database Engine. Click on this New Query tab. This opens up a window where we can write and execute SQL queries. Welcome to Prajim Technologies. I'm Venkat. This is part 1 of SQL Server. In this session, we'll understand how to connect to SQL Server using SQL Server Management Studio. What is SQL Server Management Studio and the different authentication methods that can be used to connect to SQL Server. Now, you need to have SQL Server Management Studio already installed on your machine. If not, there are several articles on the web which can help us how to do that. So once you have SQL Server Management Studio installed on your machine, to open that, go to the Start menu, select All Programs, and depending on the version of the SQL Server that you have installed, you should see a respective folder here. For example, if you have installed SQL Server 2005, you should see a folder for that here, Microsoft SQL Server 2005. On my machine, I have Microsoft SQL Server 2008, so I see a folder for that. Expand that, and within that folder, you should see SQL Server Management Studio. Now select that. Once you select SQL Server Management Studio, you should see a Connect to Server window coming up. And this is the place where we specify the information that is required for SQL Server Management Studio to connect to a SQL Server database. Now, SQL Server Management Studio and the SQL Server database are two different things. Okay, so a database server typically contains all the tables and the data, any SQL Server management object that you create. For example, it could be trigger, view, tables, data related to those tables, etc. All of that will be stored centrally on that database server. And to connect to that database server, the client tool that we generally use is SQL Server Management Studio. So keep in mind, SQL Server Management Studio is just the client tool to connect to the database server, and it is not the server by itself. So in a typical development environment, the database server might be installed on one centralized machine, and usually developers can connect to that using a SQL Server Management Studio that's installed on their respective machine. In this example, you can see that we have 4 developers, and from each of the developer machine we can use the SQL Server Management Studio, specify the information about this database server. For example, from this developer machine 1, if I have to connect to the SQL Server database, okay, I need to tell, okay, this is the server name and user ID, password, and how do you want to connect from this machine to this server? Do you want to use Windows authentication or SQL Server authentication? Okay, the point to keep in mind, SQL Server Management Studio is just the client tool and not the server by itself. And now we will see how to configure SQL Server Management Studio to connect to a database server. So if we go back, okay, so this is the window that we typically see when we open up SQL Server Management Studio for the first time. Now, the first choice that we have to make is to specify the server type. Usually, it's the database engine. Okay, but if you want to connect to analysis services or reporting services or integration services, which are also respectively called as SSAS, SSRS, and SSIS. SSIS means SQL Server Integration Services, SSRS means SQL Server Reporting Services, and SSAS means Analysis Services. We don't want to connect to any of them. We just want to connect to the database server. So that's why we use the database engine here. Okay, in a later module when we talk about SQL Server Integration Services and Reporting Services, we will see how to connect to those databases using the respective options here. Okay, for now it's database engine, and you also need to specify the server name. Now, if you have an environment like this, where you have a database server on a centralized machine, then you need to specify the name or IP address of that server. Okay, but here on my machine, the database server and the SQL Server Management Studio both are installed on my machine. The database server is also present on my local machine. So if that's the case, then I can specify the IP address of my computer itself, the local IP address, which is 127.0.0.1.
This is also called as loopback IP address if you're from a networking background. So to refer to the local machine, I can use the loopback IP address, which is 127.0.0.1, or I can also just say dot. So the dot specifies that I want to connect to the local server, or I can specify local keyword here. So any of these will tell the SQL Server Management Studio we want to find an installation of SQL Server database on the local machine and not over the network. So you can either use local, dot, or an IP address 127.0.0.1. So you can use any of these. Okay, so once we have the server name specified, then the important decision that we have to make is how do we want to connect to the database server. Do we want to use Windows authentication or SQL Server authentication? Now the options available here for you to connect depends on how you have configured the SQL Server during installation. When we are installing SQL Server, basically it provides us with two options for authenticating against that installation of SQL Server. Those two options are mixed mode authentication or SQL Server authentication. So if you choose mixed mode authentication, then it means both of these options will be available for you to connect to the SQL Server. If you have just chosen SQL Server authentication, then you cannot use Windows authentication. So the options available here for you to connect to the SQL Server are basically dependent on how you have installed the SQL Server. Okay, for now let's choose SQL Server authentication. Okay, if you choose Windows authentication, then you don't have to provide any of the username or password. Okay, that's because Windows authentication basically uses the Windows login that you have used to log into this computer. So you have already authenticated yourself to log into this computer. So basically that username and password, the Windows username and password, will be used to validate you against this database. On the other hand, you can also use SQL Server authentication. So when you use SQL Server authentication, when you are installing SQL Server again, you would have specified what is the username and password that you want to use to connect to this installation of SQL Server. So you specify that username and password. Typically we specify that as SA, system administrator, and a password for that. Okay, so we have to provide that username and password. So let's provide that username and password, and then I can click connect. So now when I click connect, it should connect to an installation of SQL Server that's locally installed on that machine. And once that's done, look at this, it has connected to the local SQL Server on this machine, and then I can basically see all the databases, okay, and the security related stuff. Now this window on the left hand side is called the Object Explorer window. Okay, where you can see the database objects. You can explore through those database objects. That's why it's basically called as Object Explorer. Now if I have to write a query, then I need a space to do that. And the first thing you have to do is click on this new query button on the top left hand corner. That should bring you up a new query editor window where basically we can type and execute queries. Okay, but again, to type and execute queries, we need a database. So what's a database? A database is a collection of tables and all your database objects. Okay, we'll see in the next session how to create a database, and we will start writing queries. Okay, now, so this is your Object Explorer. This is your query editor window, and if I just hover my mouse over there, it shows me I am connected to the local machine. And then there you see something called .master. That's nothing but the database context that we are currently in. So here you can switch the database, against which you want to write a query. Now you might be wondering, how did I get all these databases here? For example, system databases. If I expand that, I have master, model, MSDB, TempDB. So what are these? As the name suggests, these are system databases. And how did they get in here? When I installed SQL Server, they automatically got installed. And these are required for the functionality of the SQL Server. Okay, and we can also create user-defined databases, by just right-clicking on that and selecting new database, which we'll be doing in the next session. Okay, basically this session is all about how to connect to SQL Server. And the point that we have to keep in mind is that SQL Server Management Studio is not a server by itself, because many people get confused by that. It is just a client tool to connect to the SQL Server. Hello, welcome to Pragim Technologies. I am Venkat. This is part 2 of SQL Server. In this session, we'll understand how to create, alter, and drop a database. In part 1 of this video series, we have seen how to connect to a SQL Server using SQL Server Management Studio. Having connected to the SQL Server, now it's time for us to create a database. Now remember, in SQL Server, most of the things can be done in two ways. One is graphically using SQL Server Management Studio or using a query. Now let us see how to create a database graphically using SQL Server Management Studio. Let's flip back to SQL Server Management Studio. Now within the Object Explorer window, you see a databases folder. Right click on the databases folder and select a new database. And the moment we do that, you see a new database dialog box. All you have to do here is provide the name of the new database that you want to create. For example, let's say I want to create a database with name sample1 and click OK. So what's going to happen now? Behind the scenes, SQL Server Management Studio is going to issue a query to have this database created for us. So if you expand the databases folder, you should see sample1 database created there. Now we can also create a database using a query. Now let us see how to create a database using a query. Now database is also one of the types of SQL Server objects. Just like database, you can create tables, views, triggers, store procedures, etc., which we'll be talking about in a later session. But remember, irrespective of the type of the object that you're creating in SQL Server, you use the create statement. Okay, so create. Now if I want to create a database, I will say database. And on the other hand, let's say if I want to create a table, I will say table. If I want to create a view, I would say create view. Okay, so depending on the type of the object, you specify the type of the object that you want to create, which in our case is a database. So create database, and what is the name of the database that I want to create? So let's say I want to create a database called sample2. Okay, create database and the name of the database. Execute. So what's going to happen now? It creates this database sample2. So to see that database, refresh the databases folder and you should see sample2 there. And let's say for some reason, you close the Object Explorer and you want it back, just go to the view menu and select Object Explorer. So you have it back. Alright, so we have seen how to create a database graphically using the designer as well as using a query. Now irrespective of how you have created the database, when we create a database, there are two files that gets generated. Now let's look at properties of one of these databases that we have created. And look at this. These two are user-defined databases. Whereas if I expand system databases folder, you see there are some system databases, master, model, MSDB, TempDB. These databases are provided by SQL Server installation itself, and these are required for proper functioning of the SQL Server, so they should be there. So system databases and user-defined databases. User-defined databases are the databases that we create. Okay, now for every database that we have, whether it is a system database or a user-defined database, okay, there are two files that gets generated. Now let's right click on one of the user-defined databases, go into properties, and in the files tab you will have a path. Okay, so there is a path here. Let me copy that path, paste that in the run window and press enter. Now if you look at this, you see there is sample1.mdf and sample1_log.ldf. So these are the two files that are related to the database that we have just created, sample1 and sample2. So sample2.mdf, sample2_log.ldf. Okay, so what are these files? So MDF file is nothing but the data file, and this is the actual master data file which contains actual data. whereas LDF is a transaction log file, and we use this file basically to recover the database in case if there are any problems. Okay, we will be talking about these two files in a great detail in a later session, but for now understand that whenever we create a database, these two files get generated, .mdf and .ldf. MDF master data file, LDF log data file. Alright, we have seen how to create a database. Now let's see how to rename a database after it's been created. Now again, to rename the database there are two ways. One, you can graphically do that using SQL Server Management Studio, or you can write a query. And to graphically do that, just right click on the database and select rename, just like how you rename a file within the Windows file system, and then provide your new name there and press enter. The name will be changed automatically. But on the other hand, let us say how to rename a database using a query. Now if you want to do it with query, then there are two ways to do it. One is to basically use alter database command. So alter database and then the name of the database, modify name is equal to new database name. Alright, let's see how to do that. Let's say I want to change the name of sample2 database to sample3. So alter database, and I want to alter sample2 database. And what do I want to alter? I want to alter the name to sample3. So when I execute this query, what's going to happen? The name has been changed from sample2 to sample3. And if you want to see that change, just refresh this folder. So now you should see sample3. Another way to change the name of the database is to use one of the system stored procedures. Now we'll be talking about stored procedures in a later session, but understand that stored procedures are nothing but a group of commands that are executed together. We'll be talking about them in a later session, but right now understand that there are two types of stored procedures. One is system stored procedures and the other one is user defined stored procedures. Now what are system stored procedures? These are provided by Microsoft SQL Server, which are basically used for functions like renaming a stored procedure, or if you want to view the text of a stored procedure, you can use sp_help text. If you want to find out how many indexes are there on a table, you can basically use a stored procedure called sp_help index. There are several system stored procedures that we use for a variety of different tasks, which we will be looking at as we go through this course. But for now, understand that if you want to rename a database, there is a system stored procedure called sp_rename db which can be used. And to this stored procedure, obviously, if you have to change the name of a database, you will have to tell it what is the database, whose name you want to change, and what is the new name. So provide these two parameters to this stored procedure, which will do its job. Let's see how to do that. So let's say I want to change sample3 database to sample4. So sp_rename db, and what is the old name of this database, sample3, and I want to change that to sample4. So the database name sample4 has been set, and now if we refresh, you should see sample4. Alright, so we have seen how to create a database and how to alter a database. Now finally, let us see how to drop a database or delete a database. Okay, again, to drop or delete a database, you can basically do that graphically using SQL Server Management Studio or by writing a query. For example, if I want to drop this database, I can just right click that and say delete. Okay, and the moment I do that, what's going to happen behind the scenes, it will delete the MDF and LDF files that are associated with this database. Okay, so if you go to that folder, you see sample1.mdf and sample1_log.ldf. Now if I delete this graphically, so I'm deleting this database, click OK. So what's going to happen, that database got deleted, and if you go into the folder, the log files and the MDF files, both of those files should also be deleted. Okay, now we have seen how to do that graphically. Now let's see how to do that using a query. To drop any object, let it be database, table, view, stored procedure, etc., we basically use the drop statement. Drop, what do I want to drop? I want to drop a database, so database, and then the name of the database that you want to drop. let's say sample4. So when I execute this query, what's going to happen? Sample4 database will be deleted, and behind the scenes both the MDF and LDF files will also be deleted. But remember, when you are dropping a database, that database should not be in use. For example, let's understand what we mean by that. Look at this. This is the database server, and all the developers or users can connect to that database using their respective computers. Now let us say this developer is using our sample4 database, developer 1 is using sample4 database, and developer 2 is trying to delete the database. Okay, so what should happen ideally? It shouldn't be deleted, because this user will get an error because there is a query, for example, that's being executed, and while that query of developer 1 is being executed, developer 2 is trying to delete the database. Okay, so what happens at that point of time? The database will not be deleted. Developer 2 will get an error stating that the database is in use and cannot be deleted. Okay. So you cannot drop a database if it's currently in use. You get an error stating cannot drop database because it is currently in use. So if the other users are connected, you need to put the database in a single user mode and then drop the database. Okay, so if there are so many users connected to the database, then the database is set to be in multi-user mode. Okay, so you will have to bring it back to single user mode before you can actually drop that if there are people currently connected to that database that you are trying to delete. Okay, and the way we do that is we again use the alter database command. Alter database, the database name that we want to alter, and we want to set the database in single user mode with rollback immediate. What we mean by with rollback immediate? Now this option, let's say for example, if we go back to the next slide, let's say this user is actually using the database and there is a long running query. The query is taking, let's say, 10 minutes to execute, and this developer is trying to delete that, and obviously developer 2 cannot delete that because that database is currently in use. So what this guy can do, developer 2 can do, basically he can force the database to be set into single user mode, and then at that point of time he can also tell, okay, if there are any pending transactions running on that server, roll them back immediately. Okay, so this option with rollback immediate basically tells, okay, if there are any incomplete transactions, roll them back immediately and close the connection to the database. Okay, so this is the command that we use. Let us simulate that. Let's say, let's open another SQL Server Management Studio and try to connect to that, and then let's put the sample4 database into use there. So let's connect to SQL Server Management Studio. Okay, so we are connected to SQL Server Management Studio, and let's open up a new query editor window and let's select sample4 here. So it's like this is one user who is using sample4 database, and this is another user who is trying to drop the database. Now let's try to drop this database and see what's going to happen. So I'm trying to drop this database. Look at this. This query is trying to drop the database, but we are not able to do that because this user is currently connected. Okay, but on the other hand, let's cancel this query. Look at this. It's still not completed. It's waiting for that user to release that. So let's cancel this query. Let me close this connection. And now if I execute this statement, it will be dropped immediately. Or what you can basically do is you can graphically do that, delete the database, and you can say close existing connections, which will basically do effectively the same thing. Okay. Let's say if I put this database, if I select this database, currently I have selected sample4 database, and if I try to drop the database, because if you look at this, I'm trying to use that and at the same time I'm trying to drop that. Look at what's going to happen. Cannot drop the database because it's currently in use. Okay, so obviously if you have to drop a database, that database cannot be in use, otherwise you get an error stating so. Okay, so if I drop this now, the database will be dropped, and if you refresh, you should see that the database is gone now. Okay, keep that in mind. If you want to drop a database that's in use, you can use alter database name set single user with rollback immediate. And with this rollback immediate option will basically roll back all incomplete transactions and closes any connections to the database that you're trying to drop. And also a very important point to keep in mind, system databases cannot be dropped. For example, if I try to delete one of the system database, you cannot do that. You will get an error, drop database. Let's say, for example, I want to drop the master database, and if I execute that, look at that, cannot drop the database master because it's a system database. Hello, welcome to Prajim Technologies. I am Venkat. This is part 3 of SQL Server. In part 1 of this video series, we have seen how to connect to SQL Server using SQL Server Management Studio, and in part 2 we have seen how to create, alter and drop databases. In this session, we'll learn how to create tables and enforce primary and foreign key constraints between those tables. The aim of this session is basically to create these two tables, TBL person and TBL gender. Now within this TBL person table, I want to mark this ID column as the primary key column, and in TBL gender, I want this column to be marked as a primary key column. Now what is the use of primary key? A primary key basically is used to identify uniquely each record in that table. For example, in this TBL person table, if I have two Marys, how do I uniquely identify each one of them? Using this primary key column. So if there is another record for Mary, probably she will have an ID of 7. So 2 is for this Mary, 7 is for another Mary that we are going to have. Okay, so primary key is basically used to uniquely identify each record within that table. Alright, to create a table in SQL Server, we have got two options. One is graphically using SQL Server Management Studio, and the other one is basically to write a query. Now first we will see how to create a table graphically using SQL Server Management Studio. So let's flip back. So now within the databases, in the previous session we have seen how to create a sample database. So if I expand the sample database, you see there's a folder called tables folder, and if I expand that, we don't have any tables yet because we haven't created any. Now if I want to create a new table, I can right click this folder and say new table, and we want to create a TBL person table with these columns: ID, name, email and gender ID. So let's create those. So this is the table designer window. So what's the column name that we want? We want the column name as ID and the data type. Now if you look at the ID, the number, it's a number, it's an integer. So I want the data type to be integer. And should this column allow nulls? No, it shouldn't, because I want this column to uniquely identify each row within this table. So I don't want to allow nulls, so remove that checkbox. And I want this column to be the primary key column of this table. And how do I do that? Right click on that column and select set primary key. Okay, so what have we done? We have created this ID column, we have specified the data type, and we said it's not going to allow nulls, and we marked this column as a primary key column. And what's the next column in our table? Name column. Okay, and the data type of this one is going to be nvar_char, and we also have to specify the length, the number of characters. Let's say I want 50 characters. And do you want to allow nulls? No. Every person in my table needs to have a name, so remove that checkbox. And the next column we have is email, and again this is going to be nvar_char, 50 characters in length, and I don't want to allow nulls. And the final column that we want is the gender ID. Okay, so gender ID is going to be an integer, and I can allow nulls. For example, I don't know the gender of a few people. In that case, their gender ID will be null. Okay, so I want to create this gender ID column. So gender ID, and I want this to be integer, and I want to allow nulls. That's it, we are done. Now right click here and say save table 1, and I want to call this table as TBL person table. So basically what we have done now, we have used the designer and created this TBL person table. So you look at this, this is the TBL person table, and if you expand that, and if you expand the columns folder, you should see all the columns: ID, name, email, gender ID. And if you look at this, ID column has a key symbol next to that, indicating that this is the primary key. There is also this abbreviated form PK, primary key. It's an integer data type and it doesn't allow nulls. On the other hand, if you look at gender ID, it's an integer column and it does allow nulls. Alright, so we have just seen how to create a table, graphically using the designer. Now let us see how to create this TBL gender table using SQL query. Now in the previous session when we created a database, we used the command create database name. Now we want to create a table, so we will say create table and the name of the table. So create table, and what's the table that I want to create? TBL gender. Now this table is going to have how many columns? 2 columns, ID and gender columns, and we want the ID to be integer column, and we don't want to allow nulls, and we want this column to be the primary key column of this table. So how do we do that? So I want the column as ID and the data type as integer, and I don't want to allow nulls, so not null, and I want this column to be primary key. So primary key, so that's the first column, your name of the column, data type, whether you want to allow nulls or not, and primary key. Now the next column that I want to create is the gender column itself. So gender, and the data type of this column is going to be envarchar, and I don't want to allow nulls, so not null, and this is not going to be a primary key. And remember, a table can have only one primary key. And now execute this command. So command completed successfully. Now if you come here and refresh the tables folder, you should see TBL gender table. Now interestingly, you don't see the TBL gender table. Why? Because if you look at the database context here, you have created that table. You have selected here the master table. So when you executed this query, it got executed in the context of the master database. And what's a master database? It's the system database. So if you come here, expand this, you should see TBL gender here, but that's not our intention. We want this table to be created in sample database. So let's get rid of that. So that's why we need to be extremely cautious when executing a query. Are we executing that against the database that we want it to be created, or another database? So first let's get rid of this table. So delete, click OK. So the table is gone. Now to create this table within sample database, you can select the database here, or what you can do is in the script here you can say use sample database, and look at that, sample word is in blue color, meaning it's used like a keyword. So if you want to specify that as the name of the database, put it in a square brackets like this and then click go. So we are saying use the sample database, go. Now for example, if I am in the master database, if I execute just these two statements, what's going to happen? Look at this, the database is automatically changed. And now if I execute this, what's going to happen? This table will get created in the sample database. So now refresh and you should see TBL gender table here. And if I expand that and if I see the columns there, you should see ID is the primary key column. It's an integer data type and doesn't allow nulls, whereas gender is envarchar 50 and it doesn't allow nulls as well. So what have we done until now? Until now we have created these two tables and marked these two columns as primary keys for these two tables. Okay, now what else we want to do? We know that this gender ID column, we want to mark this gender ID column as the foreign key in this table. So how do we do that? Again, you can do that graphically, or you can do that using a query. First we'll see how to do that graphically and then we'll use a query. Now what is the advantage of foreign key basically? Let's talk about that practically. First let's create this foreign key relationship, and before that let's enter some data into these tables. Now in the next session we will see how to enter data using queries, but for now we'll use the designer basically to enter data. And to do that, right click on the table and click on edit top 200 rows. Before we do that for TBL person, let's do it for TBL gender. Right click on the table and select edit top 200 rows. Okay, now let's say I want to enter 1 male, 2 is female, let's say. Okay, a simple sample data that I have. Okay, so 1 is male, 2 is female. Now let's do it for TBL person. Edit top 200 rows. Now what do we have here? The ID of the person, name let's say John, his email let's say j@j.com, and his gender ID let's say 1. Okay, now this is fine. So John's gender ID is 1. So what is John's gender? He is a male. Now on the other hand, let's say I enter another person, maybe Mary, and m@m.com, but here I'm saying gender ID is 99. Okay, now look at this, that value is accepted by the SQL Server. Now if somebody asks, okay, can you tell me what is Mary's gender? Now you're looking, okay, Mary's gender ID is 99, and you go to the genders table and you don't have a 99 here. So what is Mary's gender? You don't know. Okay, so basically here the data that you have in the person table is not correct. Okay, somebody maybe by mistake they have entered this 99 and SQL Server accepted that value. So if you look at this data, the database integrity is lost. Your data is not intact. There's something wrong with this data. Okay, but on the other hand, if we have established the relationship between these two tables, the foreign key relationship, it wouldn't have allowed you to enter 99 here. But on the other hand, it would have allowed null. Okay, so if you enter null, okay, what is Mary's gender? It's null, which means we don't know. They haven't provided their gender information. But if somebody is able to enter maybe 99 or 101 like this data doesn't make any sense. Why? Because gender ID 101 does not exist in the genders table. And we don't know what is Mary's gender. So the database integrity is lost. So how do we enforce the database integrity? Using this foreign key relationship, foreign key constraints. So let us see how to add a foreign key constraint. So now let's enter this as null for the time being. Let's close this table. Let's close this table as well. Okay, now what do we want to do? In TBL person table, we want to mark this column as a foreign key constraint. Okay, let's do that graphically. So here TBL person is the foreign key table. This table contains the foreign key, and this foreign key is looking up for values in TBL gender table. So this primary key, the primary key of TBL gender is acting as a foreign key in TBL person table. So primary key table is TBL gender and foreign key table is TBL person. And in TBL person, gender ID column looks up its values in TBL gender table in this ID column. Okay, for example, if I want Martin's gender, okay, Martin's gender ID is 1. So you take this value, go into TBL gender, look in this column, 1 is male. Okay, so this is your primary key table, TBL gender, and your foreign key table is TBL person. Okay, now let's flip back to SQL Server Management Studio. So in the TBL person table, I want this column gender ID to be marked as a foreign key. How do I do that? Right click on the table and select design. And within the designer window of this table, this is the gender ID column that we want to mark as a foreign key. So right click on that and select relationships. So this shows up a foreign key relationships window. Click here, add. Now you should see tables and columns specification here. Click there and you should see an ellipsis button. Click that button. This is where you will have to specify which is the primary key table, which is the foreign key table. And we know that the primary key table is the TBL gender table. In TBL gender table, I want to look up the ID column, and the foreign key table is TBL person table. And within TBL person table, gender ID is the foreign key column. So click OK. Now if you say close and save the table, what's going to happen? This gender ID will be marked as a foreign key constraint. Okay, but let's do that using a query rather than using the designer. Okay. let's not save this. Okay, if I want to create a foreign key constraint using a query rather than the designer, how do we do that? There is a general formula for that. So alter table and foreign key table. Look at this. Alter table, which table we want to alter? TBL person table. So let's write that. So alter table TBL person. That's the table we want to alter. Why? Because in this table I want to mark gender ID column as the foreign key constraint, as the foreign key column. So alter table TBL person table. And what do I want to do? I want to add a constraint. What type of constraint? Foreign key constraint. Add constraint and then give it a name. So add constraint and give it a name. What is the name of this constraint? I'm creating this foreign key constraint on this TBL person table. So on TBL person, on which column am I creating that? On gender ID column. So gender ID, and this is going to be a foreign key constraint. So that's the name of the constraint. And next, what we need to do, we need to specify which column in this table, and that column, which other table is it going to reference, and which column in that other table. So if you look back, so foreign key, and we need to specify which column in TBL person table is going to be the foreign key. In this TBL person table, gender ID, so we specify gender ID is the column that we want to mark as a foreign key. But then if this is a foreign key, then it has to be a primary key of some other table. So which is that other table in which we have to look up the primary key column? So in our case, it's going to be the TBL gender table. So this column is going to reference TBL gender table and ID column. So references which table? TBL gender, and which column in that table? ID column. So if you look at that, primary key column. Alright, so if I execute this query, what's going to happen? It's going to create a foreign key constraint with this name. So execute that. So command completed successfully. Now if I come to the TBL person table, refresh that, and if I expand the TBL person, and if I go into the keys table, look at that, there is this TBL person gender ID FK created, this constraint basically created, foreign key constraint is created. And if you right click on that and if you say modify, you should see exactly the same thing that we have specified here. And if you come here, tables and column specifications, click the ellipsis button, you should see that the primary key table is TBL gender and the column is ID, and the foreign key table is TBL person gender ID. So you can do that either graphically or using the designer. Now, do I have to remember this, the syntax of adding a foreign key constraint on top of my head? I would say not really, but you'll have to understand the concept. That's what is important. In your interview, nobody will ask you how to, what is the syntax for adding a foreign key constraint, but they would generally ask you, can you explain the concept of foreign key constraint and why do we use foreign key constraints? That's important to understand. The syntax, you can Google that within 2 minutes. If you search Google, you will get tons of articles explaining you the syntax. So basically what we have done until now is we have created these two tables, marked the ID columns as primary keys for both the tables, and we marked gender ID in TBL person as a foreign key column. Now since we have marked this column as a foreign key column, now this column only allow values if they exist in TBL gender. Otherwise the value doesn't make sense. For example, for Rob, if I enter 99, what is Rob's gender? It doesn't make sense. Okay, so it checks that value when you try to insert or update that, and if that value does not exist in the primary key table, it's going to flag that as an error and that it doesn't allow you to enter. Let's see that in action. For example, let's go to this TBL gender table and let's say edit top 200 rows, and if you look at gender table, we only have 1 and 2, male and female. And let's go to TBL person table and edit top 200 rows there, and let's say I want to change Mary's gender from null to maybe 99. Okay, and the moment I click away, look at this, no rows updated. The data in row 2 was not committed. Committed meaning not saved. Okay, so what's the error? There is a foreign key constraint violation. Okay, so because this 99 does not make sense, okay, so let's enter null, because why? In gender table 99 does not exist. So now your data is being verified because of this foreign key constraint. If somebody tries to enter invalid data accidentally or intentionally, SQL Server is not going to save the data, and instead it throws an error. So now we are able to maintain database integrity. The data now is going to be valid. So foreign key constraint. So what's a foreign key constraint? Basically, we are using foreign key constraint to enforce database integrity. In layman's terms, a foreign key in one table points to a primary key in another table. And the foreign key constraint prevents invalid data from being entered or inserted or updated. Okay, because the values that you enter here should be one of those values present in the primary key column. Okay, otherwise you get an error. Welcome to Prajim Technologies. I am Venkat. This is part 4 of SQL Server. In this session, we'll understand how to add a default constraint. In part 3 of this video series, we have seen how to create tables. Specifically, we have created TBL person and TBL gender tables. And we have also seen how to add a primary key and a foreign key constraint. If you remember, in TBL person table, we mark this ID column as a primary key and gender ID as a foreign key. And along the same lines, in TBL gender table, we mark the ID column as its primary key. Now, if you look at the sample data that we have got in these two tables, okay, this is how we have the sample data. And if you look at the columns in TBL person table, we have got 4 columns here. The first 3 columns, ID, name, and email, they have a not null constraint, meaning whenever you insert a row into this TBL person table, you have to mandatorily supply the values for ID, name, and email columns. But whereas if you look gender ID, it's not mandatory. I mean, you don't have a not null constraint. You're saying that this column does allow nulls. It means when you insert some of the records, for some of the records you can have gender ID as null, but whereas ID, name, and email cannot be null. Okay, so let's insert a record into this TBL person table. And obviously, to insert a row into this table, you can either do that graphically or using an insert query. Let's do it using an insert query. So insert into the table name. So I want to insert the data into this TBL person table. Now you can also specify the column list. Let's say I want to insert the values for ID, name, email, and gender ID. Now gender ID, since gender ID allows null, you may or may not supply a value for that. Let's say I don't want to supply a value for that column. And then I will say values. So into this table, for these columns, we have to supply the values. So let's say, for example, the ID of the person is going to be 7, and the name of the person may be Rich, and maybe their email r@r.com. Okay, now if you look at this row that we are going to insert, we haven't supplied gender ID, and since it's nullable column, it means this column allows null. So when I execute this query, and when we select the rows from this table, you should see that Rich record has got null there. Okay, now let us say when somebody doesn't supply a value. Now if you look at the TBL gender table, for example, here, okay, if you don't know the gender of a person, I would recommend, I want the data to be inserted in such a way that they will get, by default 3. Okay, so it's, instead of storing null, I want to store a default value. Okay, if we don't know the gender of a person, rather than allowing nulls there, I want to insert number 3, so that anybody, when they look at this data, okay, Rich gender ID is 3, so his gender is unknown. Okay, so I want to have defaults. So how do we do that? Using a default constraint. But if you don't have a default constraint, and if you don't supply a value for a nullable column, then by default it will get null value there. But on the other hand, you can control that using a default constraint. So in this case, let's say anytime we insert a record into TBL person table and I don't supply a value for gender ID column, I want the default number 3 to be inserted. Okay, let's see how to do that. So to add a default constraint, Okay, here is the syntax: altering an existing column to add a default constraint. So obviously we are changing the definition of the table, so we have to say alter table, in this case TBL person, and what do we want to do? We want to add a constraint, add constraint, and give a meaningful name to that constraint, and default, and then whatever is the value. In our case it's going to be 3 for gender ID column within this TBL person table. So let's do that. So to add the default constraint, alter table, and which is the table that we want to alter? TBL person table. So alter table TBL person. Now how do we want to alter this table? We want to add a constraint. So add constraint, and give the constraint a meaningful name. Since this is going to be a default constraint, I would give an abbreviated form df, and then we are adding this constraint to this table, so include the table name as well, so TBL person. And for which column we are adding that? We are adding it for gender ID column, so specify the gender ID column as well. So just by looking at the name, the constraint name, you can say, okay, this constraint is for TBL person table, and it's a default constraint for which column? Gender ID. So give a meaningful name to your constraint, and then what type of constraint is this? This is a default constraint, and you can specify the value. In our case, the value is going to be 3 for gender ID column. So 3 for gender ID. Okay, so when we execute this query, look at that. If you look at the TBL person table now, if you expand constraints, you don't have anything there, but once we can create this constraint, we should get that there. So let's execute this query. So command completed successfully. Now if I go ahead and refresh the constraints folder of TBL person, we should see the default constraint created there. Now let's insert. If you look at the records in TBL person table now, we've got 7 records and Rich has got null. Now let us say I want to insert somebody here like Mike, and his ID is 8, and let us say mike@or.com. And if you look at this query, we are still not supplying the gender of this person, Mike's gender. Now, but we have added a constraint. So what should happen now? If you do not supply a value for gender ID column, then this constraint, will insert default value, which is 3 for the gender ID for Mike. So let's see how, let's execute and see what happens. So when I execute this, one row has been affected, and if you select all rows, look at this. For Mike, we didn't supply a value, so it took the default. But on the other hand, if I supply a value, let us say I'm going to enter somebody, I'm going to pass the gender ID as well, because I know the gender ID of the person. And let's say I'm going to say this time Sarah. Let's say her email ID is s@r.com, and I want to supply gender ID for her. I know she is a female, so I'm going to pass the value for that. So when you pass the value, you're specifically saying Sarah's gender ID is 1. So now the default will not be kicking in. So this value will be stored for Sarah. So when I execute that, and when you check TBL person, you should see her gender ID which we have supplied. And finally, let's do this. Let's say I'm going to insert maybe John's record, whose ID is going to be 10. We already have John, so let's say Johnny, for example. Let's say his email ID is j@r.com. Now I am passing in the gender ID, but I am specifically saying I don't know his gender, so I'm just going to say null. So you are specifically passing null value, which means will the default be assigned or will it not be assigned? Now let's execute and see what happens. So I executed that query. Johnny is the latest record that we have inserted, and if you look at the result for Johnny, it didn't take the default. Why? Because if you supply a value, even if it is null, the default will not be executed. Okay, instead the value that you have supplied will be inserted into the table. But in the other case, if you miss the value or if you don't supply a value, that's when default will be considered. Okay, so we have seen how to alter an existing column to add a default constraint. It's also possible that when you're creating a table, or if you want to add a new column to a table for an existing table and you want to have a default for that column, it is still possible adding a new column with the default value to an existing table. And this is the syntax: alter table, and the table for which you want to add this new column, you add that column, specify the data type, whether it allows nulls or not, and then constraint, give it a meaningful name and the default value for that. Okay, and how to drop a constraint? You can use alter table command, drop constraint, and the constraint name. Okay, so if we want to drop this constraint, we can use drop constraint statement. But before that, we have to use alter table. So alter table tbl person drop constraint and the name of the constraint. So in our case, the name of the constraint is this one. So when I press F5, the constraint will be dropped. So if we refresh this constraints folder on the left hand side, that should be gone. So it's possible to assign a default to a column using the default constraint. Hello, welcome to Prajim Technologies. I'm Venkat. This is part 5 of SQL Server. In this session, we'll understand what is cascading referential integrity constraint is all about. Now, to understand this session properly, I strongly recommend watching parts 3 and 4. In part 3, we have seen how to create tables and add primary and foreign key constraints. And in part 4, we have seen how to add a default constraint. If you remember, we have been working with tables tbl person and tbl gender in parts 3 and 4. And we have marked this gender ID column as a foreign key column within this tbl person table. So if I ask you what is the gender of Jade, what will you do? You'll check the value of this gender ID column, go to tbl gender table, check okay, number 2 is female, so Jade's gender is female. Now let's imagine what's going to happen if I delete this female record from tbl gender table. Obviously, Jade and May records will have no meaning. So if I ask you what is Jade's and May gender, number 2, we don't have a corresponding record here, so we will not be able to tell their gender. So these two records, Jade and May, will become orphan records. That's why by default SQL Server doesn't allow these kinds of deletes. Okay, let's flip back to SQL Server Management Studio. And if you look at the sample data that we have within these two tables, now if you look at Simon, the gender of Simon is 2, which is female. Now let's imagine what's going to happen if I delete this female record from tbl gender table. Mind you, in tbl person, there are still rows referring that value. So obviously, when I try to delete, I get an error. Okay, look at this. The error says there is, the delete statement conflicted with the reference constraint tbl person gender fk. Okay, so what is this tbl person gender fk? If you remember, in part 3 of this video series, we have created a foreign key constraint with this name, tbl person gender fk. So what is this constraint saying? This constraint is basically saying, so if we expand this tables and column specifications, so in tbl person, the gender ID column is referring to ID column in tbl gender. So that's what we have said using this foreign key constraint. Okay, now if you look, if you scroll down a little bit in this foreign key relationships window, there is this insert and update specification. And by default, if you look at the delete and update rule, it is set to no action. So the default is no action. So if it is set to no action, and when you try to delete any of the existing rows, for which there are references in tbl person, obviously if we allow that row to be deleted, these rows will become orphan records. and that kind of a delete will not be allowed by default, okay, which is no action. So if you remember, for specifying the cascading referential integrity, you have 4 options. The default is no action, in which case you get an error and the statement will be rolled back. Okay, but you can also specify cascade, set null, and set default. First, let's look at set default. Now, if you remember, in the previous session, we have seen how to set a default using a default constraint. So if you look at the constraint that we have already on TBL person table, so it's called default on TBL person on gender ID column, and we specified that if somebody doesn't supply a value for the gender ID column, then we want to use a default of 3. That's what this default constraint does. And if you're not sure how to set up a default constraint, I strongly recommend watching the previous session in this video series. Okay, now what you can basically do is, in this foreign key constraint window, in insert and update specification section, let's say if somebody tries to delete a row, I want to set it to a default. Click OK, save the changes. Now if somebody tries to delete, okay, we already have a female record. We have this female record here. If somebody tries to delete this female record from TBL gender table, we said any dependent rows, set it to default, and the default that we have here is it's going to set that to 3. Okay, so now let's try to delete this and see what's going to happen. And we select the data back. You should see Simon gender ID set to default, which is 3. Okay, and along the same lines, you have other options as well. You can either cascade the delete and update operation, or you can set to null. Okay, let's see how set null works. So obviously, if you want to change the update and delete cascade operation, so you come to the insert and update specification. In the delete rule, let us say I want to set null instead of set default. Close and save it. Now let's go back to the tables. So in TBL person table, if you look at this, there are, let's say, John and Rich. Their gender is male. Now let us say I want to delete this male record. So what did we specify in cascading referential integrity? We said, use set null. Okay, so when I delete this male record from this table, from the primary key table, what's going to happen for the dependent rows? The gender ID for the dependent rows will be set to null. So in this case, John and Rich rows will be set to null. So let's execute that. Now let's select the data back. So John and Rich gender ID is set to null. Okay, and the final option that we have is cascade. Okay, as the name suggests, we want to cascade the update and delete operation to the dependent table. Okay, so how do we do that? Go into the foreign key constraint window. In insert and update specification section, instead of set null, we will say cascade. Close that, save. Now if you look at in TBL gender, we have number 3 unknown, and there are 3 people, Simon, Sarah and Johnny, whose gender ID is unknown. Now if I go ahead and delete this record from TBL gender table, all the dependent rows will also be deleted from TBL person table. So in this case, these 3 rows will be deleted. Okay, so gone all. Those 3 rows are gone now. Okay, so basically, there are 4 options available for you when setting up cascading referential integrity constraint. The default is no action. If you set this option, by default you get an error and the update and delete statements will be rolled back. Otherwise, you can cascade the updates and deletes, or you can set null. The dependent rows can be set to null, or they can be set to defaults. Hello, welcome to Pragim Technologies. I am Venkat. This is part 6 of SQL Server. In this session, we'll understand what check constraint is and when do we use it. Now, Check constraint is used to limit the range of the values that can be entered for a specific column. Let's understand this with an example. I have this table called TBL person, which has got this age column. In reality, age of a person cannot be negative, and along the same lines, it's impractical for a human being to be alive after 150 years. So the age column, should be taking values between 0 and 150. Okay, but if you look at the data type of this age column, it's an integer. By the way, if you want to find out the the data type of any column in SQL Server, there are several ways. Okay, one of the easiest ways is you expand the tables folder within the database, and you go to that specific table and expand the columns folder, and you can see that the age column is of type integer and it allows nulls. This is one way. Another quick way to find out the information about the columns that are present inside the table is highlight the table and press Alt F1. So that should bring up the columns and their respective data types as well. So if you look at the age data type, it is of type integer. So since age is integer data type, it can allow any valid integer. For example, let's try to insert a row into this table. So insert into TBL person, let's say I want to insert ID of 4 and the name of the person may be Sarah and email s@s.com and maybe gender ID, since she is a female, let's say 2, and age. Now look at this, since age is of type integer, I can enter something like -970. Okay, and if I try to execute this query, the row will be happily accepted into the table. So for the age column, I'm able to enter an invalid age. Okay, so is it possible to prevent numbers like this being entered? See, all I want to allow with this column is a number between 0 and 50. If anybody tries to enter a number outside of that range, I want to throw an error. Is that possible? Absolutely, using the check constraint of SQL Server. It checks the values while you enter them, and then if it falls outside that range, it throws an error. So how do we add a check constraint? Like any other constraint, check constraint can be added to SQL Server in two ways. One is graphically using the designer, the other one is obviously using a query. Now first let's see how to do that graphically using the designer. So since it's a constraint, you can go on to the constraints folder in SQL Server Management Studio. By the way, you have to be in the table, under the table folder. So I want to do it for TBL person table, so expand the TBL person table. There you should see a constraints folder. Right click on that and select new constraint. So this should bring up a check constraints window where we can basically add the constraint information. Now remember, a constraint is just a Boolean expression which returns a true or a false. Okay, now what's our aim? Our aim is that the age column shouldn't be allowing a number less than 0 or greater than 150. Okay, so how do we do that? You add that expression here, and whatever expression that you enter here should be a Boolean expression. It should return a true or a false. If it returns true, then the value will be allowed to be entered. If it returns false, then it doesn't allow the value. Okay, so what we want to do is the age should be greater than 0, and age should be less than 150. So anytime anybody is supplying a value for this age column, it has to be within that range. It has to be greater than 0, less than 150. Click OK. And another thing that we have to do is give it a meaningful name. Okay, just by looking at the name, you should be able to tell, okay, this is a check constraint on this table for this column. Okay, and the common convention is that for a check constraint we use ck prefix, ck underscore the name of the table on which we want to create that constraint, and for the column to which we want to create that constraint. In this case, it's the age column. And then you have another option here, check existing data on creation. Okay, so what does this mean? If there is already invalid data which doesn't fall into this criteria, this constraint will fail. It basically will not succeed in getting created. Okay, so it checks the existing data. So you can turn this off, or alternatively you can delete that bad data. Okay, let's close that, but then when I try to save it, that's when we get an error, so unable to add this constraint. Okay, so what we will do first is we will go ahead and delete that invalid row. So which is that invalid row, the record with ID 4. So let's delete that from that table. So delete from TBL person where ID is equal to 4. So we deleted that invalid row. Now all of the rows are valid for us. So now let's try to save this, and it gets saved. Okay, now let's try to execute this query and see what's going to happen. So when I try to execute this query, look at that, the check constraint is kicking in. It's telling, okay, the insert statement conflicted with the check constraint ck underscore tbl person underscore age, the constraint that we have just created. On the other hand, if I supply a valid age, maybe 10 years, and if I try to execute this query, it happily gets inserted. So if we select all the rows from the table, you should see that Sarah has got the age of 10 right now. Okay, now let's do one more test. Let's say we are inserting another Sarah with ID 5, and let's say here, instead of passing a value for age, now remember, age column is a nullable column, which means you don't have to supply a value for that. You can just pass null. Okay, so if I pass null, what is going to happen to that Boolean expression that we have written? Okay, now if you remember, the Boolean expression is age should be greater than 0, and at the same time it should be less than 150. Now is null greater than 0 or less than 150? This is an unknown value. The Boolean expression returns an unknown result, in which case the constraint passes and allows null to be inserted. So if we run this query will be executed. Why? Because the Boolean expression doesn't return false, it just returns unknown, because you cannot compare null with anything. So it doesn't return false, that's why it allows nulls to be inserted. So you can add nulls, and you can add any valid values that fall within 0 and 150. Okay, so how do we drop a constraint? Now you know that we have added this constraint using the designer. So obviously if we expand this folder, you should see that constraint there. Okay, so we have this constraint. Now how do we delete this constraint or drop this constraint? Again, you can do that graphically, or you can use a command. To do it graphically, you just right click on that and delete. And if you want to use a command, a SQL Server query, it is just like dropping any other constraint. So obviously if you want to drop a constraint, it's like you're altering the table, because the constraint is for the table. So we have to tell we are going to alter the table. So alter table. Which table is that? TBL person. And how are you going to alter this table? I'm going to drop one of the existing constraints. In this case, the check constraint that we have created. Let's refresh this, and we should see that check constraint there. Okay, so I want to drop this constraint. So let's copy that constraint name. So alter table TBL person drop. What do I want to drop? I want to drop a constraint and then specify the name of the constraint. So you press F5, command completed successfully. Let's refresh the folder, and the constraint shouldn't be there anymore. Okay, now let's go ahead and see how to add a constraint using SQL query. Now if you look at the presentation, it's very simple. The general formula for adding a check constraint, not only check constraint, any constraint for that matter. Okay, so alter table, table name, add constraint, the name of the constraint. So here we are adding a check constraint, so we use this check keyword and then a Boolean expression. If you remember, while we are doing it graphically, we did it in that Boolean expression window, but here we have to do that within this parenthesis. Okay, so let's see how to do that. So alter table, table name, and what we want to do, we want to add a constraint. So add constraint, and then you have to give the constraint a meaningful name. So check constraints by default will have a CK prefix underscore the table for which we are adding this constraint. In this case, it's going to be TBL person, and for which column? It's going to be for age column. And then what type of constraint are we going to add? Check constraint. and within the parentheses we have to specify the Boolean expression. What should be our Boolean expression? We don't want to allow values for age, less than 0 or greater than 150. Okay, so age should be greater than 0 and age should be less than 150. That's it. So I press F5, command completed successfully, refresh the constraints folder, and you should see the constraint once again. And if we try to add any value, something like maybe 950 years, press F5, it should give an error. Alright, so that's how we do that. And remember, if this Boolean expression returns true, the check constraint allows the value, otherwise it doesn't. Since age is a nullable column, it's possible to pass a null value for this column when we are inserting a row. So when you pass a null for this age column, the Boolean expression evaluates to unknown and allows that null value. So it's possible for you to insert nulls, because why? The Boolean expression that's involved there returns an unknown result. Okay, so when will a check constraint prevent a value from being entered? Whenever the Boolean expression returns false. Okay, and to drop a constraint, we have seen we use this alter table and drop constraint, the name of the constraint. Welcome to Prajim Technologies. I am Venkat. This is part 7 of SQL Server. In this session, we'll learn everything about an identity column. What is an identity column? How to create an identity column? How to supply explicit values for an identity column? And how to reset values of an identity column. Now, to understand this better, let's look at the existing table that we have been working with in all these parts. Now, we have this table called TBL person, and if you look at this TBL person table here, it has got 4 columns: ID, name, email, gender ID, and age. And if you look at the ID column here, it's a primary key column, but it's not an identity column. Okay, how do I know it's not an identity column? If you go to the properties of that particular column, in the properties window, you see that identity, it is set to false. So it's not an identity column. So if a column is not an identity column, then in SQL Server you will have to supply a value for that. For example, when I try to insert a row into this table, a new row into this table, how many columns are there? We have 1, 2, 3, 4, 5 columns. So we have to supply the values for all the 5 columns, including the ID column. Now let's say I want to insert Todd's record. So the ID is 7, name is Todd, email, gender ID, and age. So if we go ahead and execute this query, it gets inserted fine. But if you look at the ID column, why are we using this primary key column? Basically to uniquely identify each record in this table. Let's assume if there are 2 Sarahs, if I want to uniquely identify them, I use their ID there. Now, IDs usually are some things that users need not have to provide. For example, if you have a web application, let's say you are registering as a customer, you don't provide your customer ID through that registration form. That is something we want to have automatically calculated by SQL Server. Okay, so under those circumstances, we can actually make use of the identity column. Okay, so if you mark a column as an identity column in SQL Server, you don't have to supply a value for that. Now let us see how to create a table with an identity column. Okay, since we already have a table called TBL person, let's try to create another table called TBL person 1 maybe. So I'm going to create this table. I'm going to call, maybe we'll call this person ID. And obviously it's an integer. Now if you look at this particular column, select that column and then drag this column properties window, and you see that there is something called identity specification. And if you click the plus sign next to that, you see that is identity. Okay, do you want this column to be an identity column? Yes, I want this column to be an identity column. Okay, and if you look at it, as soon as I have selected yes, there are 2 other properties here: identity seed and identity increment. What are these? Basically, you are saying, by converting this person ID column into an identity column, you're telling SQL Server you want the value for this column to be automatically computed when we insert a new row. Okay, now if you want the value to be automatically computed, you have you can specify how you want that to be computed. For example, do you want that value to start at 1 or do you want to start at 100? Okay, so that's the seed. Okay, where should I start? Usually it's 1 by default, but you can customize that. For example, if you want to start at 1000, you can do so. Just put seed as 1000 there. And how much do you want to increment by every time when you add a new record? Do you want to increment by 1, 2, 3, 4, 5, or 10 or 100? Okay, let's say for example I want the initial record to have 1000, and every next record that I insert needs to be incremented by 5. Is that possible? Absolutely. Put that increment as 5, and every new record you insert, it will be incremented by 5. But it doesn't make sense in reality. In reality, it usually the seed is 1 and the increment is 1. But remember, you can customize that if you want to. Alright, so we specified the information that is required for marking a column as an identity column. And since I want this to act as a primary key, I can select primary key. Otherwise, you can just leave it. It's up to you. So I select it as primary key, and then maybe the name of the person. Let's say this is nvar of 50. That's all I want at this point. Let's save this table. Let's call this tbl person 1. Click OK, which should create that table. Okay. Now, if you look at that column, let's close that. So if you look at tbl person 1, if I expand columns, refresh, so we have this person ID column, which is again set as primary key. And if we go to the properties window, you should see this is an identity column, true, seed at 1 and increment at 1. Cool. Now, if I have to insert a row into this particular table, so select star from tbl person 1, so we don't have any rows in there. So if I want to insert a value into this table, insert into tbl person 1, values, look at this. Now, how many columns have we got within this table? Within this table, we have got 2 columns. Now, and we know that person ID is an identity column, so we don't have to supply a value for that. All I have to do is supply the value for name column. For example, let's say John. And when I execute this query, what's going to happen is, since we specified the seed as 1 and increment as 1, it's going to start at 1 and then put person ID as 1 for this user, John. So let's execute that. When we select all the rows from this table, look at that, I get this person ID 1. And on the other hand, let's say for example, if I insert Tom's record, execute that, select that row, we should have automatically got 2. So it's incrementing by 1 because we specified that during marking that column as an identity column. Alright. Now, so I have marked this column as an identity column. Now everything is fine. I'm inserting new records, and the person ID is automatically being calculated, which is good. Okay, so at the moment we have person ID 1, 2, and 3. Let's say for some reason, maybe John has left our company or something, and this record got deleted. Let's delete that record. Delete from tbl person 1, where person ID is equal to 1. So when I delete that row, you see that, okay, I have Tom and Sarah, who is number 2 and number 3. Now let's say there is another person called Todd, and I want to add him to our database. When I insert him, and when we select the data back, look at that, Todd gets a person ID of 4. It doesn't reuse the ID that is not there. There is a gap here. Number 1 record is basically not present, and when I insert a new record, I want to reuse that old value. Is that possible? Absolutely. Okay, there are several ways to do that. Let's see first of all how to supply. Now let's say for example, I'm going to insert maybe another record, Jane, and I want to issue him person ID of 1. Is that possible? Absolutely. Okay, let's pass in person ID here and see what's going to happen when I try to insert that record. Remember, person ID is an identity column. You don't have to supply a value for that. It will be computed by SQL Server automatically. However, here, since we want to reuse that person ID of 1 with Jane user, I'm supplying this value explicitly. And let's try to insert this and see what happens. Okay, when I press F5, look at that, we get an error. Okay, what does the error say? An explicit value for the identity column. So an explicit value for the identity column in table TBL person 1 can only be specified when a column list is used and the identity insert is on. So which means you have to do some changes here if you want to explicitly supply a value for an identity column. Okay, first of all, you have to turn the identity insert on. Okay, so for this table I want to tell to SQL Server, okay, I'm going to supply the values for identity column explicitly. And how do you do that? By turning this identity insert on. So let's do that first. Okay, so to turn the identity insert on, you'll use the set command. And what is that? Identity insert. Copy that. Set identity insert. So for what I need to set the identity insert? For this table TBL person 1 on, all you have to do is this. So when I execute this query, okay, command completed successfully, which means we have turned on the identity insert for this TBL person 1. And the next thing that we have to do is when we insert this query, look at this. If I mean, we have turned the identity insert on, but when I execute this query, I get the error again because we have done half of it. We need to supply a column list as well. So in the insert query, not just the values, I need to specify what these values are for which column. I want this values for person ID and name columns. And now when I execute this query, you should see that Jane has got ID value of 1. Okay, now since I have this identity insert turned on, is it possible to drop this value and just supply name? What happens in that case? Look at that. Let's try to, I'm not going to pass a value for person ID column. And let's say, for example, I want to insert Martin. So I'm just supplying a value for the name column. Okay, but keep in mind we have the identity insert turned on for this table. So when I execute that query, look at this, explicit value must be specified. Why? Because you have the identity insert turned on. So if you don't want to supply the value explicitly for the identity column, then you have to turn off that, because you fill the gap. So let me turn off so that when I insert the next record, it's going to get the next incremented value for that column. So when I press F5, it's turned off right now. And when we insert this guy now, we are going to get a new ID for that person. Now the sequence continues. Okay, one way to explicitly supply values for identity column is basically to turn on the identity insert. Cool. So we basically have seen. So remember, if a column is marked as an identity column, then the values for this column are automatically generated. Okay, when we insert a new row into the table, we don't have to supply values. But there might be scenarios where you have deleted some records and there are gaps generated and you want to fill those gaps. You can temporarily turn off identity insert and then fill those gaps. You can turn on identity insert and then fill those gaps and turn off identity insert. Alright, now let's say I've deleted all the rows from this table and I want to reset the identity insert. The value for identity column. Is that possible? Absolutely. Let's do one thing. Let's delete everything from TBL person. So I'm going to delete all the rows from TBL person 1 table. And look at this, when you delete all the rows from TBL person table, don't assume that it's going to reset the values for identity column. Okay, so when I select rows from the table, obviously there wouldn't be anything. And now when I insert a new row for Martin, and when we select that row now, look at this, it's getting the next identity value. It's not resetting that value. Okay, so if you have deleted all the rows and you want to reset the identity value, is that possible? Absolutely. We have some commands called DBCC, database consistency check commands, which we'll be talking about in a great detail in a later session. But understand at the time being that we have this DBCC command which we can use to reset the identity value and then start again at 0. So how do we do that? We use that dbcc check identity, basically dbcc check identity for this tbl person, reseed that starting at 0. Okay, starting at 0. So let us see how to what this command does. So I'm going to say dbcc check identity. That's the function. And for which table we want to do that? We want to do that for tbl person 1 table. And what do we want to do? We want to reseed starting at 0. Okay, look at this. When I execute this query, what's going to happen? Okay, so we basically have deleted everything from this table. So there's nothing there. So when we execute this command, look at that. Current identity value 0, current column value 0. Now, if I am going to insert this row now, what's going to happen? The current identity value is 0. And if you remember, we have set the increment value is 1. So for this new row Martin, it's going to get 1 and insert that. It's going to start that again. So now when we select the values from tbl person table, you should see that Martin has got 1. Okay, so it's also possible to reset the values for identity columns if you have deleted all the rows in the table by using this dbcc check identity command. We'll be talking about dbcc commands in SQL Server in a later session. Welcome to Prajim Technologies. I am Venkat. This is part 8 of SQL Server. In this session, we'll understand how to retrieve the last generated identity column value. In SQL Server, we can use scope underscore identity, attr identity, or ident underscore current functions to retrieve the last generated identity column value. In this session, we'll also talk about the differences between these three approaches of retrieving the identity column value. Now, if you haven't watched part 7 of this video series, I strongly encourage you to do so before continuing with this session. Now let's create two different tables. So let's say I have a table called create table test1. It's going to have an ID column which is of type integer, and I want this column to be identity column with seed s1 and increment s1, and I want a value column which is going to be nvarchar of 20. Okay, let's create another table and let's call it test2. Alright, let's create these two tables now. Execute the query, refresh the tables folder, and you should see both this test1 and test2. Now, let's insert a record into test1 table. Insert into test1 values. And if you remember, in test1, ID column is an identity column, so we don't have to supply a value for that when we insert a record into this table. So just supply the value for name, the value column. Okay, so I'm going to pass X to this value column of test1 table. Now, when we insert this record, what's going to happen? A record gets inserted into this test1 table. Now let's retrieve the data that's there. So select star from test1. So when you retrieve the row, this ID column is automatically generated by SQL Server and it got inserted into this table. Now let's say I want the last generated identity column to be retrieved. Okay, how can I do that? Basically, one way is to use scope identity function. Okay, there's a function called scope identity within SQL Server which we can use. So select scope identity. So when I press F5, look at that. The last generated identity column value is 1, so I get that. Let's insert this record again. Now there is another record inserted. If I press F5, look at that. The last generated identity column value is 2. Okay, so I have the scope identity function. Now it turns out that there is another global variable that we can use at identity. So there is another way to retrieve the last generated identity column value. So select edit identity. When I execute this, let's execute both of them together. So when I execute both of them together, what's happening, they give us the same result. So then what's the difference between these two? Let's understand that with an example. Now the reason why we have created two tables, you'll understand that now. Okay, let me create a trigger on test1 table. Now we haven't spoken about triggers yet, which we'll be talking about in a later session in a great detail. But for now, understand that you can create a trigger on a table for a specific action. For example, let's say I have this test1 table. When I insert a row into this table, I want some processing to be done automatically. So is that possible? Yes, we can do that. How is it possible? Using triggers. So we can create a trigger on a table for a specific action. For example, whenever somebody inserts a row into test1 table, I want another row to be automatically inserted into test2 table by a trigger. Okay, so let's create a trigger on test1 table. So create trigger. Let's call this tr for insert on test1 table. For what action? For insert action, as begin end. So your trigger definition goes between this begin and end statements. Now if you look at this one, we are creating a trigger called tr for insert on test1 table for insert action. So whenever somebody inserts a row into test1 table, whatever you specify here will be executed. Okay, what I'm going to do here is I'm going to insert a row into test2 table. So insert into test2 values, and I'm going to say here maybe a value of YYY. Now if you remember, in test2 again we have an ID column and value column, and ID is an identity column. Okay, so let's create this trigger and execute this. Okay, so we have now test1 and test2 tables. And if you remember, on test1 table we have an insert trigger as well. So let's select and see what's the current state of the data. In test1 record we have two records. In test1 table we have two records. In test2 table we don't have any records. Now when I execute this insert statement, what's going to happen? This trigger is also going to get fired. So this trigger now will insert a record into test2 table. So now when we execute this insert query, there are two rows that are going to be inserted. One row into test1 table, another row by the trigger into test2 table. Okay, and then once we do that, let's take these two. Okay, let's insert the value first. So when I press F5, look at that, you get this message, one row affected twice. That's because one for this insert statement and one for the trigger itself. So now when we execute these two, look at the result. Okay, scope identity gave me number 3, whereas edit identity gave me number 1. Now let's execute. Okay, so 3 is from test1 table, 1 is from test2 table. Okay, so what's the difference between scope identity and edit identity? Now the similarity is both of them returns the last generated value. Now scope identity returns the last generated value in the same session. Session is nothing but a connection. So if you look at this, I just have one query editor window open which is connecting to the SQL server. So I just have one session to the SQL server. So in the same session and within the same scope. Okay, so if you look at this, I just have this insert statement. When I execute this, the scope is just this insert statement. So within the scope, okay, scope identity has returned a value which is 3. But whereas edit identity, when this statement got executed, there is a trigger defined on that table, and trigger inserted another row into another table, which in turn generated another identity column value. Okay, edit identity returned that value. Okay, so if you look at the presentation, Scope identity returns the last generated identity value in the same session and in the same scope, whereas attach identity returns the last generated identity value in the same session but across any scope. Alright, now let's understand what do we mean by ident_current function. When do we actually use this, and what's the difference between this and the rest of these two. Now if you look at this ident_current function, basically if you look at the function name itself, it's expecting a table name parameter, meaning you pass the name of a table. So when you pass the name of a table there, it's gonna give you the last generated identity column value for that table, okay, but across any session and any scope. Okay, now session is nothing but a connection to the SQL Server, a new connection. Okay, so let's see. Now you can assume that this as one session. So let's say user1 session is this one. Let's open another query editor window. So this is like another session. Okay, now let's say I'm inserting a value into test2 table. So insert into test2 values, and I'm gonna say maybe ZZZ. And let's take the same query and go to user2's window. Okay, so now it's like this is one session and this is another session. Okay, now let's say select ident_current function, and look at this. This function expects a table name. The IntelliSense shows that you need to pass in the table name parameter here. So let's pass the table name, which is nothing but test2. Alright, so let's execute this query. So insert into test2, okay, and we are executing that in user1's connection. So execute that. Let's go to user2 session and execute this one. Okay, and within user1 session I am running this ident_current, all these statements. Okay, let's run them and then we'll understand. Okay, so scope identity, attach identity. Now look at this, both of them are returning number 2 because they operate only within the current session. They don't consider the other sessions. But whereas ident_current function, okay, it operates across any session but for that test2 table. So if you look at test2 table, it should have got 3 records now, and the last record was inserted by this user2 session, okay, which is 3. The identity column value is 3. So your ident_current function returns the last generated identity column value for that table across any session and any scope, whereas attach identity returns the last generated identity value within the same session, that means within the same connection, but across any scope. But whereas scope identity returns the last generated identity column value within the same session and within the same scope. Okay, most of the times in reality we use scope_identity function to retrieve the last generated identity value so that we can return that back to the user. For example, if you have an application where maybe a customer is registering with your company or with your product, you need to give him a product ID. Okay, so as soon as they register and the record is inserted into the table, we need to select the record that has just been inserted, the identity column value for that record, and then return it back to the application so it can be displayed on that web page, and the user will know, okay, this is my customer number. Okay, so usually in order to retrieve the last generated identity column, we use scope_identity function, but there are other options as well available, and we have seen the differences between them in this session. Welcome to Prajim Technologies. I am Venkat. This is part 9 of SQL Server. In this session, we'll understand what a unique key constraint is, when do we use unique key constraint or primary key constraint, and the differences between unique and primary key constraints. Now, We use unique key constraint to enforce uniqueness of a column. That is, the column shouldn't allow any duplicate values. If you remember, in this video series, we have already discussed a primary key is also used to enforce uniqueness of a column. So when do we choose one over the other? Now, we know that a table cannot have more than one primary key. Now let's say in my table I have person ID, which is already a primary key, and I also have email ID, social security number, passport number columns, and I want to maintain uniqueness of each of these columns. Okay, so is it possible to do that using primary keys? No, because why? A table can only have one primary key. So that's when you make use of this unique key constraint. Okay, a table can have more than one unique key constraint. So this is one of the primary differences between a primary key constraint and a unique key constraint, and this is one of the very common interview question that's asked these days. So if you look at this, a table can have only one primary key but more than one unique key. So when do we choose unique key constraint over primary key constraint? If there are multiple columns in a table where you want to maintain uniqueness, then we go for unique key constraint. Okay, another difference between primary and unique key constraints is that primary key doesn't allow even one null, whereas unique key allows one and only one null. So these are the two differences between primary key and unique key constraints. Now, to create a unique key constraint, again, there are two ways. One, using the designer of SQL Server Management Studio, and obviously the other one is to use the query. Now first let's see how to create a unique key constraint using the designer. So we already have this TBL person table, and this table has got 4 columns: ID, name, email, gender ID, and age. ID column is already the primary key column. So if I have one column as primary key, it's not practically possible to mark another column as primary key. Okay, so that's when I use a unique key constraint. Now I want to ensure the email column is always unique. So how do I do that? By creating a unique key constraint. So how do we create a unique key constraint? Right click on the table for which you want to create a unique key constraint, select design, and in the table designer window, right click on any of the columns and select indexes/keys, which should bring up select primary or unique key index window. So look at this. Here you can create primary keys as well as unique keys or indexes. We haven't spoken about indexes yet. We'll be talking about them in detail in a later session. Okay, so we already have a primary key on this ID column, so that's that key. Now let's add another key for a unique key constraint. Okay, since this is a unique key, usually the naming convention is UQ and the name of the person on which you are creating that unique key constraint and the column. Now in our case the column is email. Okay, so you can select your columns here, click on the ellipsis button and select your column, email column. So I want to maintain the uniqueness of email column, and you can specify the sort order. We'll talk about this sort order when we talk about indexes. And is unique? Yes, I want this to be unique, and this is not an index. I want to create a unique key. Close it, save this table. Okay, now if we save this table, obviously we end up creating unique key index. Let's not do that. Let's go and try to create that using a query. So how do we create a unique key constraint using a query? Now just like adding any other constraint, you add the unique key constraint in the same way. Obviously when you're adding a unique key constraint, you are altering the definition of the table, so you have to use alter table statement. So alter table TBL person, and how do we want to alter the table? By adding a unique key constraint. So add, what do we want to add? We want to add a constraint and give the constraint a meaningful name. So UQ for unique key constraint underscore, on which table are you creating this constraint? On TBL person table, and on which column? Email column. Okay, so we are adding a constraint with this name, and obviously what type of constraint are you adding? A unique key constraint, so unique. And for which column are you creating this? email. So that's it. So execute that. Now if you refresh the keys folder, expand this, you should see UQ TBL person email. Now let's try to insert a row into this table and see what's going to happen. So since this table has got 4 columns, we have to supply the values for these 4 columns. So insert into TBL person values, value for ID, let's say 1, name, let's say ABC, email, this is what is a.a.com, a@a.com, and gender ID, let's say 1, and age, let's say 20. Now let's insert this row. Okay, so if you look at this table, we've got a@a.com. Now let's try to insert maybe another person whose name is XYZ, and by mistake, or he is intentionally entering this a@a.com. Look at this, and remember, we already have a unique key constraint on this column. So if I try to enter this query, execute this query, we should get a unique key constraint violation error. So let's see that. When I press F5, look at this, violation of the unique key constraint, and look at the name of the constraint that we have created, UQ TBL person underscore email, and it clearly says cannot insert duplicate key in object TBL person. Alright, so how do we drop this constraint? Now, just like how we drop other constraints, we drop unique constraint in the same way. Obviously there are 2 ways to do that. One is you can go to the constraint, right click on that, and you have an option to delete that, or you can do that using a query. So how do we do that using a query? Drop constraint. So we want to drop a constraint and the name of the constraint. What's the name of the constraint? UQ TBL person underscore email. So when I press F5, obviously we have to use the alter table command. So alter table, which table? TBL person. And how do we want to alter that? By dropping the constraint. So press F5, so the constraint is dropped. Refresh the folder, and you should see that's gone. And if I try to execute this now, I will be able to insert a duplicate value for email address. Look at this, I have this duplicate. Welcome to Presume Technologies. I am Venkat. This is part 10 of SQL Server. In this session, we'll talk everything about the select statement in SQL Server. We'll first see how to select specific columns or all columns. Okay, now if we want to select all the columns from all columns and all rows from TBL person table, we will say select star from TBL person. When we execute that query, we get all the results, all the columns and all the rows. Now another way to select all the columns from a table, instead of specifying the star here, you can specify the column list. And if you're lazy typing in all the column names, you can ask SQL Server to write the query for you automatically. So go into the database, go into that table, right click on the table, script table as, select to, new query editor window. So what it is going to do for us, it will write the query for us. Look at this, these are all the columns I want from this table. But then if you look at the table name here, in the from class, we have a 3-part table name. Okay, the first one, sample, is nothing but the name of the database, and the second part is the schema, and the third part is the name of the table itself. Now we haven't spoken about database schemas yet. We'll be talking about them in a later session. Okay, so this is the fully qualified name of the table. Now what's the advantage of having a fully qualified name? Even if you don't have the context of the database selected, look at this, I am in the context of the master database, but since I have a fully qualified name, when I execute this query, the query gets executed fine. But on the other hand, if I don't have the fully qualified name, if I just have the table name, and if I try to execute this query, obviously it will try to find the table in the master database and we get an error. So the advantage of having a fully qualified name of the table is that you can run it from any database context. Okay, so obviously to select all the columns from a table, you can either use star or you can specify the list of columns. Okay, for performance reasons, it's always better to receive to specify the entire column list rather than just saying star. Alright, so that's the first thing, selecting specific columns or all columns. Now how to select distinct rows? Let's understand what we mean by that. Okay, in TBL person table, you see that, if you look at the city, there are some duplicates. There are 2 people living in London. Now let's say I want all the distinct cities that are available in this table. How do I do that? I can use the distinct keyword. So select distinct city from TBL person. So when I execute that, look at this, we have a total of 5 rows, out of which London is repeated twice, and I want distinct cities from this table. So when I execute this, I only end up getting 4 rows. Okay, London is repeated only once: London, Mumbai, New York, Sydney. Now let's execute this one again. Now let's say I want distinct city and the name of the person. Okay, so let's say, now let us see how many rows we get and what result we get. So when I execute this query, look at this, I got 5 rows back. And why did it give 5 rows? And if you look at this, London is repeated twice. Now it's not giving me distinct city. Okay, but we have used distinct keyword. So what happened to that? Now when you are saying distinct keyword and multiple columns, you are actually telling SQL Server the value should be distinct across these 2 columns. So if you take these 2 columns, they will be distinct. So when you use distinct keyword across more than 1 column, you're specifying it's enough for the values to be distinct across all those columns, when you put them together. So that's selecting distinct records using the distinct keyword. Filtering the values with the where class. Now when I say select star from TBL person, I get all the records from the table. Now let's say I want only the people who are living in London. How do I filter them? You use the where class. Okay, so you use the where class and you specify your condition in the where class. So what's your condition in the where class? I want all the people who are residing in the city of London. So London. So what's going to happen? This expression will return a true or a false. If it returns true, then that record is selected for the result set, otherwise not. So there are 2 people living in London. So when we execute this query, we should get only 2 records. Okay, and you can also we'll talk about that in a bit anyways. So you can use the where clause basically to limit the number of rows that you want to return. Now if you want to select all the people who are not residing in London, instead of specifying multiple city names here, what you can do is you can specify where city not equal to. By the way, that's the not equal to operator in SQL Server, greater than and less than symbol. So not equal to London. When I press F5, I get every person who are not living in the city of London. Okay, and you can use another operator, that is exclamation and equal to. Even this is considered as not equal to. So you can either use greater than or less than, or exclamation equal to. Alright, so now when you use the where class to filter the rows, there are several operators that you can use with the where class. We have just seen how to use equal to and not equal to. Let's see what other operators are available for us. So these are the variety of operators that are available. So we have seen how to use equal to and not equal to. Similarly, you can also specify greater than or greater than equal to, less than or less than or equal to, and these are very easy to use. Obviously they are self-explanatory. Apart from these operators, we also have other operators. For example, in operator, this is extremely useful. Now if we look at all the people that we have in our database, okay, there is an age column and there are several people with different ages. Now let us say I want to select all the people whose age is 20, 23 and 25. So how do I do that? You want to specify multiple filters. So you can say where age is equal to 20, or age is equal to 23, or age is equal to 25. Instead of specifying multiple conditions, look at this. If I have to do that, I want to select people with age is equal to 20, or age is equal to 23, or age is equal to maybe 29. So if I have to do that, I'll get all the people whose age is 20, 23, and 29. Okay, but it's many conditions, many conditions concatenated using the OR symbol. Okay, instead of doing this, you can actually rewrite this query using the in operator. Select star from TBL person, where age in, you can just say 20, 23, 29. And this is much simpler and easier to understand as well. So I want all the people whose age is within that list. So if you want to specify a list of values, then you use the in operator. Okay, now you can also use the between operator if you want, let's say for example, I want all the people whose age is between 20 and 25. I can use the between keyword. Okay, so select star from TBL person, where age between 20 and 25. So when I execute this query, I get all the people whose age is between 20 and 25, and these boundary conditions 20 and 25 are inclusive. Okay, so to specify a range of values, then we use the between operator. Now, and the interesting and very useful operator is the like operator, which can be used to specify a pattern. Now let's see how to use the like operator. Let's select all the rows that are present in TBL person. Now let's say I want all the people whose city name starts with L. Okay, so how do I do that? Select star from TBL person, where city is equal to, I want all the people who resides in a city that starts with letter L. So you can say L, so it starts with L, but percentage. Okay, now you cannot use equal to here. I want to use like operator. So what you are saying is the city column should have this pattern. It should start with L, and after L it can have any character. Okay, so if we execute this query, all the people living in London. Okay, let's get all of them back again. Let's say I want to find out all valid email addresses. Now obviously, one of the quick things that we can check to find out if an email is valid or not, we can find an @ symbol. If there is an @ symbol in their email address, you can at least say, okay, it's the right format of the email. So I want to find out all the email addresses which has got an @ symbol within that. How do I do that? I can say @ symbol there, but there should be something in front of it. Any character in front of an @ symbol, any character after the @ symbol, but there should be an @ symbol in the email column. So where email like. So when we press, total we have 5 rows within the table. When I execute this query, I am only getting 4 rows, which means there is one invalid email. Now let's find out what is that invalid email. You can use the not operator. Give me all the rows which not like this pattern. So when I press F5, so Mary didn't provide her valid email address. She is missing the @ symbol. We know that every valid email should have that @ symbol. So basically, you can use the like operator with for specifying a pattern. So we use the like operator to specify a pattern, and with the like operator we use something called wildcards. So here the percentage is a wildcard. We are not specifying what exactly is the character. It's just like a placeholder or a substitute for some characters. It could be 0 or more characters. Okay, so there are several wildcards in SQL Server that we can use. One of them is the percentage, which can be used as a replacement or a substitute for 0 or more characters. And along the same lines, we have an underscore. This is underscore, not dash. Underscore, which is used as a substitute for exactly one character. Let's understand what we mean by this. So if you look at TBL person table. Okay, now let's say I want to select all the email addresses that has exactly one character before the @ symbol and one character after the @ symbol. How do I do that? You can say, okay, I want to select all the email addresses which has got one character before the @ symbol. Okay, if I have an email address something like this, a@a.com or b@b.com, I want to retrieve all the email addresses like this, which has got one character before the @ symbol and one character after the @ symbol. After that, it needs to be .com. So .com. So I want something like this. Okay, so you're using the underscore to specify there should be only one character before and after that @ symbol. Now if I execute this, you should see we get all the email addresses. Okay, now if you look at this, we got the negative results. That's because we used the not operator there. So when I press F5, we get those email addresses which has exactly one character before and after the @ symbol. So we can use underscore for that to specify exactly one character, and you can use a square brackets. You can use these square brackets to specify a list of characters. Now let's say I want to select all the people from TBL person table, maybe whose name starts with specific characters. Now let's say if a person name starts with T, I want that person. If a person name starts with M or S, I want that person's name. Okay, so basically we want all the people whose name starts with MST. Okay, how do we do that? Select star from TBL person, where name like, you specify those square brackets, and within the square brackets you can specify, and obviously you need to have single quote. By the way, keep in mind, anytime you are using a character or a text data type, okay, that has to be specified within single quotes. If it's numeric values, then you don't have to specify, single quotes. But if it is text data, text values, you will have to specify that in single quotes. Okay, so we want all the people whose names starts with MST, and after that it can be any characters, we don't really care, but the name should start with MST. So when we execute this query now, you should see everybody whose name starts with M, S, and T. And after that, it can be Tom, Mary, ARY or SARA. So basically, we use square brackets to specify a list of characters. And if you want to select all the people whose names doesn't start with MST, all you do is you specify this symbol here. Okay, this specifies not in this list. So when we execute this query, you should see that we will get everybody whose name doesn't start with MST, in this case Josh Records. So these are the wildcard operators that can be used with a pattern. So we have seen how to filter the rows using the where class, and we have also seen how to use the wildcards that are available in SQL Server. And we can also join multiple conditions using and or operators. We have seen an example of that in a bit. Now let's say I want to select all people who are living in London or Mumbai and whose age is greater than 25, greater than or equal to 25. Okay, so how do we do that? So here the conditions are, there are multiple conditions. I want all the people who live in London or Mumbai and their age should be greater than 25. So select star from TBL person, where city is equal to London or city is equal to Mumbai and age should be greater than 25. Okay, so you have to put this parenthesis here between these two conditions, because what we said, the city should be equal to London or Mumbai, and at the same time their age should be greater than 25. So one of these two conditions should be true and their age should be 25. So you can join multiple conditions using or and operators. So if we select this query, obviously we'll get all those people who are living in city, London or Mumbai, and at the same time their age greater than 25. And we can use order by clause to sort the results of a query. So let's say when I select all these rows from this table, okay, they are coming in the order of this primary key 1 2 3 4 5. Only this primary key is sorted. Now let's say I want to retrieve all the people from this database, but their names should be in ascending order of alphabets. Okay, how do I do that? Select star from tbl person, order by, we use order by class to sort the results, name. So when I press F5, what it's going to do, it's going to sort these results by the name. And look at this, it's sorted by default in the ascending order. Okay, if you don't specify the sort order, by default it's the ascending order. You can also specify to sort the name in descending order by using the DESC keyword. So when I press F5 now, the names will be sorted in descending order. And it's also possible you can sort by multiple columns. For example, I want to sort first by name in the descending order, then by age in ascending order. Is that possible? Absolutely. Okay, order by name in descending order, then by age in ascending order. You can specify as many columns as you want. So it sorts first by name and then by age in descending order. Look at this, name is in descending order, and within this name Josh is repeated twice, so their ages are sorted in ascending order because you specified sort by age in ascending order. And selecting top n or top percentage of risk, this top keyword is especially useful if the table is large. Okay, let's say I have a table where I have thousands and thousands of records, and I just want to see a sample set of records in that table. But when I say select star from tbl person, it's going to retrieve all the rows from that table, and it might take maybe 2 to 3 seconds depending on the size of the table, and it can affect performance negatively. So if you want to see just the top 10 or 5 records of a table, you can use the top keyword. How do we use that? You can just say select top. Maybe I want the top 10 records from this table, so select top 10 star from tbl person, which only gives 10 records. We don't even have 10 records here. So let's say select top 2 records. So select top 2 star. So it gives you all the columns. You can either specify star here or the columns that you want. Let's say I just want the name column and maybe age column. You can specify the columns as well. So select top 2 name comma age. Or if you want all the columns, you just say top 2 star. So you can specify an absolute number here, or you can specify a percentage. Let's say I want only top 1% of the rows. Okay, you can also use the percentage. So when I press F5, top 1% in 5 is only 1. Okay, on the other hand, let's say top 50%, it's about 2 to 3 records in the 5 records that we have. So we get 3 records, top 50%. So you can either specify an absolute number, top 10 records, or top n percentage, 10%, 50%, etc. Now this top keyword is especially very useful to achieve something. Let's say one of the common interview questions is, how do you find the top salary of an employee? Okay, in our table we don't have salary column, but we have an age column. Let's say I want to find the eldest person in this table. How do I do that? You can use the top keyword for that actually. So let's see this. Select star from tbl person, order by age DESC. So what is this going to do? This is going to select all the records from tbl person table ordered by age in descending order. So if you look at this, Josh is the one who has got 29 years of age, and that's the top record. So what you can do here is select top 1 star. So what it's going to do on this ordered result, it's going to give you the top record, which is nothing but the eldest person in our table. Okay, similarly you can do this, you can apply the same logic for an employee table and salary column, where you get the top paid employee. So we got Josh, whose age is 29 years. Welcome to Pragim Technologies. I am Venkat. This is part 11 of SQL Server. In this session, we'll talk about how to group rows using group by, filtering groups, and the difference between where and having clauses. Now, if you look at the definition, The group by clause is used to group a selected set of rows into a set of summary rows by the values of one or more columns or expressions. It is always used in conjunction with one or more aggregate functions. Now, what are the different aggregate functions that are available in SQL Server? There are many. For example, we have sum, average, count, minimum, maximum, etc. Let's look at them now. Now, if you look at this table, I've got the salary column, and let's say I want the total salary that I'm paying within my organization. So obviously, what will you do if you have to do it manually? You will take each row and add them together. But in SQL Server, we have an aggregate function called sum, which we can use. So select sum. So what do you want to sum? I want to sum the salary. So salary from TBL employee. So all you're saying is, okay, total this salary for me. So that gives us the total salary. So we are using this aggregate function. Similarly, if you want to say, let's say for example, I want to find out what is the minimum salary that I'm paying, within my organization. If you have to do it manually, you'll have to inspect each row and say, okay, 4,500 is less than greater than 2,800. Okay, I think 2,800 is the minimum salary. But in SQL Server, we have the aggregate function which we can use minimum. Okay, I want the minimum salary from this table. So when we execute this, we should get the minimum salary. And along the same lines, we have the max function as well, which gives us the maximum salary. So max of salary. So when we press that, we get that. Okay, so like this, we have several aggregate functions in SQL Server. So if you look at the definition, it says group by clause is always used in conjunction with one or more aggregate functions. Okay, now let's understand group by. So if you look at this table, I've got an employee table which has got their names, genders, salary, and the city they are working in. Okay, now I want you to write a query, let's say, and that query should give me the result that you see on the right hand side here. I want the total salary that I'm paying to my employees by city. Okay, how do we achieve this? Using group by. So if you look at this from a, if you have to do it manually, okay, what will you do? You will take each London record and then add their total salaries. Similarly, you take each New York record and add their salaries. Okay, so you first group the records by city and then sum the salary column across that group. So even the query has to do that. So that's why we use group by clause here. So let's see how to use that. So if you look at the query that we have written already, we are using this sum aggregate function to total the, to sum up the entire salary that we are paying to our employees. Okay, now this is the total salary of the organization, but I don't want the total salary of the organization. Instead, I want the total salaries paid by city. So in our output, we not only want the total salary, we also want the city. Okay, so in our select list, we need to have the city as well as the total salary. Now, if you look at this, for the total salary, we didn't have a column name. So let's give a column name by using as, and we will say total salary. So this is an alias name for this column. Cool. So now let's, okay, look at this. Select city, sum of salary from TBL employee. Okay, you're saying, okay, I want the city and the total salary, but you should also tell I want to group, okay, by city. So group by city and then calculate the total salaries across that city. Okay, so when I execute this query, you should see the same output. So the city names and the total salaries. Now let's see what's going to happen if I remove this group by clause and then execute this query. Now by looking at itself, you should, it should make sense. This is going to give an error because you're saying, okay, select city column. Okay, I select the city column and select the sum of salaries. Okay, so you're saying you want city column and the total salary, but you're not telling the query to group them by city and then total the salaries. Okay, if I don't use the salary city column, then it makes sense. Okay, I want the total salaries in the entire table. But when I use the city column, you should tell it, okay, group by city as well. So obviously, if I execute this query, you will get an error stating that tblemployee.city is invalid in the select list because it's not contained either in an aggregate function. So we cannot apply an aggregate function to a text column. What does it mean when you say some cities? You cannot sum cities, London, New York. Okay, similarly, you cannot find the average of city names itself. Okay, it's only on numerical columns you can apply the aggregate functions like sum, average, etc. Okay, so we cannot use an aggregate function like sum, average on this column, and it's not part of group by as well. That's why it's invalid in the select list. Okay, so that error makes sense. Okay, so the columns that you use in the select list, okay, they have to satisfy one of these two conditions. You should either have an aggregate function applied on that column, or that column should be part of group by clause. If none of these conditions are met, then you get this error. Okay, so the moment we put city in the group by clause, this condition is met and we don't get that error. And that makes logical sense as well. We don't have to really mug and remember that. It makes sense. You're asking, okay, give me the total salary and the city column, but you're not telling it to group by city column. So how will SQL Server know how it has to total those salaries? All right. So obviously, if you omit the group by clause and try to execute the query, you get this error, and we have seen this. So if you look at in the output, we are retrieving total salaries by city. Now let's take this one more level. Not only by city, I want to break it down further by gender. So if you look at the next slide, look at this. I want the output like this. Okay, in the previous example, we are showing the total salaries paid by city, but now I want to break it down even further by gender as well. For example, in Sydney, how much is the total salary that I'm paying for male and female employees? So if you look at the example here, for male employees within Sydney, we are paying 2,800. For female, it's 4,800. So I want this breakdown as well. So we are grouping now by multiple columns. Okay, so we are grouping this total salary first by city and then by gender. Okay, so how do we do that? It's pretty simple. If you look at the output itself, it should make sense. Okay, in the select list, we should now have three columns. We already have city and total salaries columns. We want the gender column as well. So let's put that in the select list. So I already have city. I also want gender. So select city comma gender. Now if I execute this query without any further modifications, let's see what's going to happen. You should have already expected we get the same error that we got before. Gender is invalid in the select list because you're not applying an aggregate function on top of it, and it's not part of the group by clause. So we get the same error here. So gender is invalid in the select list because it's not contained either in an aggregate function or the group by clause. So we need to make it part of the group by clause to tell SQL Server Engine, all right, I want you to total the salaries first by city and then by gender, because we want that breakdown in that order. So when we execute this query, you should see the output that we have here. It's slightly different here. The cities are together. For example, if you look at Sydney, they're next to each other. New York, they're next to each other. But if you look at our output, it's not so. So obviously we use the order by clause to order the result. And if you're not sure on what is order by clause, I will strongly encourage you to watch the previous video in this series. So order by city. So when we execute this, it should match the output on the presentation. All right. Now you might be wondering, okay, I have by city, by gender breakdown. Let us say I want by gender and by city. Probably something like I want first maybe gender and then maybe city. So I want first by gender and then by city. In this order, you just change the order. and execute this query, you get the same result, but the columns have just switched. Okay, first by gender and then by city. Cool. Okay, now let's take this even more, to the next step. Now we have seen we can group based on multiple columns. Now let us say if it's possible to use multiple aggregate functions. Absolutely. Here we are showing total salary by city and by gender. Let's say I want total number of employees as well. Now, if you remember, if you want to find out the total number of employees, we can use, let's say, if you look at this TBL employee table, we've got 10 rows there. And if I want to find the total number of employees within my organization, I can say count of star from TBL employees. When we press that, we get the total count, which is 10. And for performance reasons, instead of using star, use a specific column name, maybe ID. So I get the same result. Okay, so what is it that we want? We not only want total salaries by city and by gender, we also want the total number of employees. So if you want the total number of employees, we use the count aggregate function. So count of ID. And if you want to give a meaningful name, we will say total employees. Okay. And when I execute this, you should see we have total employees as well. Okay, so total salary by gender, by city, and total number of employees. And you might be wondering, why did I use the square brackets here? If you want to have a space in the column name, then you have to use the square bracket, otherwise you get an error. So if I remove the bracket, okay, we get an error because it treats these two as two different words. But you can, if it's just one word, you don't have to have a square bracket around it. So if we execute this, we end up with the same result. Alright, so we have seen how to use multiple aggregate functions as well. Okay, now let us see how to filter the groups. Okay, now so far we have seen, okay, we got all the result, but let's say I want to see only male salaries. I don't want to see female salaries. So how do I filter that? Okay, now usually to filter the rows, we can use the where clause, where you can say gender is equal to male. So when I execute this query, what is going to happen? It's going to show us only the male employees total salaries and total number of male employees. Okay, the other way to get the same result is, instead of using the where clause, we can use having clause, but having clause should come after the group by. Okay, if you remember, select star from table name where. Okay, so after the from clause we usually have the where clause, but having clause has to come after the group by clause. So now having gender is equal to male. So when we execute this query, we end up getting the same result. Now let's see what's the difference between these two queries. Here we said having where gender is equal to male, and in this query we said where gender is equal to male. And if we execute them together, you should see we exactly have the same output, but the way the query gets executed is a little different. When you use where clause, from the table only male records are retrieved and then they are grouped. Okay, but whereas in this, when you use the having clause, all the rows from the table TBL employee are retrieved, they are grouped by gender, and then only male groups are shown, filtering female groups. So here aggregations are done for every row in this table, whereas here aggregations are not done. They are filtered even before the aggregations are done. Only male set of records are retrieved from the table and then aggregated. But remember, it's possible to filter the output either using the where clause or having clause, but it depends on how you want the output. So you can either use the where clause or having clause. Okay, from a performance standpoint, you cannot say that one method is less efficient than the other. SQL Server Optimizer analyzes each statement and selects an efficient way of executing it. And as a best practice, use the syntax that clearly describes the desired result. Try to eliminate rows that you wouldn't need as early as possible, probably using the where clause. Okay, so now we'll talk about the difference between where and having clause. Now you might have already understood one difference by now. Where clause filters rows before aggregations, before groupings are performed, whereas having clause filters groups after the aggregations are performed. Okay, and another difference is that you can use having clause only with the select statement, whereas where clause can be used with other than select statements as well, like insert and updates as well. And aggregate functions cannot be used in the where clause. Let's see this. Okay, what do we mean by aggregate functions cannot be used in the where clause? Examples of aggregate functions we already discussed: count, average, sum, minimum, etc. Okay, so let's say select star from TBL employee, where let's say sum of salary greater than 4,000. Can I do this? Absolutely no. I mean, you can do that. There is a way to do that, using a subquery and having clause, which we'll be talking about in a later session when we talk about subqueries. Okay, but in general, you cannot use aggregate functions with the where clause, whereas aggregate functions can be used in the having clause, and that's what we have seen until now. For example, here, when you're filtering, you can say having maybe sum of salary greater than 5,000. So when we execute that, we don't get the rows where the sum of salary is less than 5,000, less than or equal to 5,000. So you can use aggregate functions with the having clause, but you cannot do that with the where clause. Welcome to Pragim Technologies. I am Venkat. This is part 12 of SQL Server. In this session, we'll understand the different types of joins that are available in SQL Server, specifically cross-join, inner join, and outer joins. Before continuing with this session, I strongly recommend watching parts 3 and 5 of this video series. Now, joins in SQL Server are used to retrieve data from two or more related tables. In general, tables are related to each other using foreign key constraints. So I have this employee table on the right here, which has got ID, name, gender, salary, and department ID columns. And then I have the department table itself here, which has got the department name, the location that department is present at, and the department head. Now if you look at these two tables are related using this foreign key department ID. Now if you're not sure what foreign key is, please watch part 3 of this video series. So these two are related tables. Now let's say I ask you to write a query which will give me an output as shown here on the left hand side. I want the name of the employee, gender, salary, and the department name. And if you look at the output columns that I require, the first three columns, name, gender, and salary, they are present in the employee table, whereas the department name is present in the departments table. So both, these columns, all these columns are not coming from a single table. They're spread across two different tables. So obviously, if I have to retrieve this output, then I will have to join these two tables. Okay, so to join these two tables in SQL Server, we have got different types of joins. For example, we have inner join, outer join, and cross joins. And again, the outer joins in SQL Server, which we'll be talking about in a bit, are divided into three different categories: left outer join, right outer join, or full outer join. Okay, you can say left outer, right outer, full outer, or you can just say left join, right join, or full join. Now let's talk about inner join. Now let's say, I want output like this. I want the name of the person, their gender, salary, and the department name. Okay, so let's see how we do this using inner join. Okay, and look at this. If you have two tables, in the inner join, the matching rows between the two tables are retrieved. For example, if you look at the employee table here, everybody has department ID except James and Russell. If you look at James and Russell's record, the department IDs are null, which means these rows doesn't have a matching department ID from the departments table. So when I join these two tables using inner join, only the matching rows between these two tables are retrieved, which means the matching rows between these two tables are these 8 rows from 1 till 8, which is what I'm getting. And if you look at the output, I don't get James and Russell's records. Why? Because their department ID does not match with the ID column in the departments table. So inner join will only give you matching rows between both the tables involved in a join. Now let's see how to write the inner join query itself. So if you look at the two tables that we have, in employee table we have got 10 rows, and in the departments table we have got 4 rows. And what do we want? We want the name, gender, salary and department name columns in the output. From which table? From TBL employee table. And the first 3 columns are present in TBL employee table, but the department name column is present in the departments table, so I will have to join with that table. And to join with that table, you use the join keyword. So TBL department. So we are saying I want to join TBL employee table with TBL department table. Okay, now if you want to join these two tables, how do you want to join these two tables? What's the common column between them? The common column is the department ID column. And to specify the join condition, you use the on clause. So on TBL employee, so in the table employee we have the department ID column, so use that to look up TBL department table and the ID column within that table. Okay, so it's pretty simple. Select whatever columns you want from TBL employee. Now I want to join this table with the TBL department, so we use the join keyword. On, how do you want to join those two tables? Now between these two tables, the common column is the department ID. Department ID in TBL employee table, join that with ID column in TBL department table. So obviously if we execute this query, we should get 8 records. Okay, now if we execute all of them together, okay, and if you look at the output here in the messages, in the TBL employees table we got 8 rows, in departments we got 4 rows, and in the join query we only got 8 rows. Why? Because if you look at James and Russell, their records doesn't have a matching department ID. That's why inner join has not returned those 2 records. So if you look at the join output, we don't have James and Russell's records in the output. We only have the matching records between these two tables. Okay, and when you write an inner join query, you can say inner join or just join. I would say always write inner join, because this will say your intentions explicitly. Okay, alright, so that's about inner join. So inner join returns only the matching rows between both the tables. Non-matching rows are eliminated. Okay, now let's say my requirement is in such a way that I not only want the matching rows, I want the non-matching rows as well from the employees. So basically I'm saying I want all the employees, irrespective of whether they are assigned to a department or not. I want all the employees. So how do we do that? So indirectly you are saying, okay, I want the matching rows plus the non-matching rows from the employees table, which means you want everything from the left table matching and non-matching. Okay, that's when you actually go for left join. So if you look at left join, returns all the matching rows plus non-matching rows from the left table. So there are 8 matching rows. So this department ID matches all. For these 8 rows, the department IDs match with the department IDs, but these 2 rows doesn't have a matching department ID. Okay, so but in departments table we have total 10 rows, so all matching and non-matching rows will be retrieved when you use a left join. So when we write a left join query, we should get 10 rows. So how do we write the left join query? Everything remains exactly similar, except that instead of inner join you will say left join. That's it. Look at this. Previously we have got 8 records when we executed that query, but let's now execute this and see how many records we get. So we first go to the messages. Look at this. In employees table we have got 10 rows, in departments 4 rows, and in the query left join query that we have written, we've got 10 rows again. So if you look at the output, now we should have got both James and Russell's records as well, but if you look at the department name column, it's basically null. And it makes sense. Why? Because they don't have a department ID. They are not assigned a department yet, so that's why department name will be null. Okay, so left join basically returns all the matching rows between both the tables plus non-matching rows from the left table, and this picture depicts exactly that scenario. And when you use a left join, you can say just left join, or you can say left outer join. Okay, the query results will not be affected, so the outer keyword is optional there. Alright, now let's say I want all the rows from the right table, including, if you look at the two tables here, you have a department called other department, and the department's ID is 4. Now this no employee in the employees table belongs to this other department. Okay, so if there is a requirement, if somebody asks you, okay, give me all the employees, okay, which means I want all the matching records between both the tables plus non-matching records from the right table. Okay, so from the departments table I want other department record as well, irrespective of whether there is an employee assigned to that department or not. So we want all the rows from the right table, okay, plus all the rows including the non-matching ones. Okay, so basically right join will return you all the matching rows between both the tables plus non-matching rows from the right table. Okay, so let's see what happens if we convert this left outer join to right outer join. Okay, so between employees and department table there are 8 matching rows, and in the TBL department table there is this other department which no employee belongs to this other department. Okay, so obviously this other department row does not have a matching record in employees table. Okay, and we want this record as well. Okay, so how do we do that? Using right outer join. So when we execute this, we should get around 9 records. So 9 records. So look at this, all the matching rows until Sarah we have got, and other department row. Okay, and if you look at the name, gender and salary columns are null. Why? Because no employee is assigned to this department, so obviously you will not have any name, gender or salary. Okay, so obviously whenever you want to return all the matching rows between both the tables that are involved in a join plus non-matching rows from the right table, that's when we go for right outer join. Okay, so you might have guessed by now, if I want all the matching rows between both the tables plus non-matching rows from the left table and non-matching rows from the right table, then what type of join do I use? Full join. So full outer join gives me exactly that result. These are the matching rows from both the tables. These two are non-matching rows from the left table, and the last row here, other department, is the non-matching row in the right table. Full outer join will give you all the records from both the left and right tables, including the non-matching rows. Okay, so obviously when we execute this query, we should get around 11 records. 8 matching records plus 2 non-matching from left and 1 non-matching from the right table. So how do we write a full outer join query? Just specify full outer join. So when we execute this query, you should see until here all these are matching records, these two are non-matching records in the employee table, and this is a non-matching record in the departments table. So together we have 11 records. Again, you can specify full outer join or just say full join. Okay, so far we have seen inner join, left join, right join, and outer join, full outer join. Okay, but apart from all these types of joins, we also have another join called cross join. So what does a cross join do, and how do I write that query? First, let's write the query, and we'll look at the output, and then we'll decide what cross join is going to do. So If it's a cross join, instead of saying full outer join, all I say is cross join. Now remember, a cross join will not have an on clause. Okay, I'll tell you in a bit why a cross join shouldn't have an on clause. So when I delete that cross join, and then when I execute this query, look at this. Look at the number of rows that we are getting, 40 rows. And if you remember, how many rows are there in these tables? 10 rows in the employees table and 4 rows in the departments table. And when we execute the cross join query, we are getting 40 rows. So basically what's happening, the number of rows in the employees table is being multiplied by the number of rows in the departments table. So a cross join will give us the Cartesian product of the tables that are involved in the cross join. Okay, so that's what cross join is all about. Cross join produces the Cartesian product of the two tables involved in the join. For example, in the employees table, if we have 10 records, and in the departments table, if we have 4 records, a cross join would produce 40 rows between these two tables. And as I told you, cross join shouldn't have an on clause. Okay, so what basically a cross join does is it will take each record from the right table and then associate that with every record in the left table. So in the departments table, we have got 4 rows, IT, payroll, HR, and other department. So it will take IT row from the departments table, associate that to every one of the employee in the employees table. And similarly, it will take the next record, which is payroll, and associate that. So it basically gives us, the number of rows in the employees table multiplied by the number of rows in the departments table. So it gives us a Cartesian product. And since this gives us a Cartesian product, it doesn't really make sense to have an on clause for cross join. Okay. And look at this. So far we have seen, writing query for joins. We have seen how to write inner join, left outer, right outer, full outer, and cross join. Now, depending on what we have done until now, it's pretty simple to develop a generic formula for joins. So what is that? Select what columns you want, or just say column list. Okay, select your column list. For example, I want name, gender, salary, department name, etc. Select column list from maybe your left table, and then you specify the join type, inner join, cross join, whatever. And once you specify the join type, with which table you're joining, so right table, and on clause for specifying join condition. Okay, so if you compare this with what we have, okay, look at this. If it's an inner join, it would have been something like this. So inner join, and on we will have tbl department dot id is equal to tbl employee dot department ID. So if you compare this generic formula with this inner join query, it exactly fits in. Select whatever columns we want from clause, the left table, and then the join type. Here it's an inner join, so we are specifying inner join. Otherwise, if it's a cross join, left join, we say left join, right join, etc. And then finally on clause and your join condition. So this is the generic formula, if you have a hard time, remembering the syntax for joins. Alright, so in summary, cross join returns the Cartesian products of the tables involved in the join, whereas inner join returns only the matching rows. Non-matching rows between the tables are eliminated. Look at these pictures, which will make the understanding of joins pretty much easy. Okay, so if you look at the inner join, only matching rows, left join, matching rows plus non-matching rows from the left table, and right join, matching rows plus non-matching rows from the right table. Whereas full join, matching rows between both the tables, non-matching from the left and non-matching from the right. Welcome to Pragim Technologies. I am Venkat. This is part 13 of SQL Server. In this session, we'll discuss about advanced or intelligent joins in SQL Server. As part of this, we will see how to retrieve only the non-matching rows from the left table, and along the same lines, how to retrieve only the non-matching rows from the right table, and finally we will see retrieving only the non-matching rows from both the left and right tables. Before continuing with this session, I strongly recommend watching part 12 of this video series. Now in part 12 of this video series, we have seen how inner join, left join, right join, and full join works. We have seen examples of that. If you recollect from that part, inner join retrieves only the matching rows between both the tables, whereas left join retrieves the matching rows plus non-matching rows from the left table, and right join matching rows plus non-matching rows from the right table. Full outer join matching rows from both the tables plus non-matching rows from the left table as well as non-matching rows from the right table. Now if you look at all these joins, the queries underneath them, they are pretty much identical, and the only difference you find is the type of join. Rest of the query is almost identical. So if you look at here, it's inner join, but whereas in the left join you just say it's a left join. For right join, and for full join you say full join. That's the only difference. Otherwise the query is identical. Alright, now let's assume, okay, so if you look at these four types of joins here, all the types of joins, they give you the matching rows plus non-matching parts. Okay, so but let's say I want an output like this. Okay, I want only the non-matching rows from the left table, and along the same lines I want only the non-matching rows from the right table, and maybe finally I want only the non-matching rows from the left table and the non-matching rows from the right table. Okay, so basically in this three result sets we are actually excluding the matching parts. In the previous slide we see in all the four types of joins we are getting the matching rows plus something extra. Okay, but here no matching rows at all. Non-matching rows from the only non-matching rows from the left table, only non-matching rows from the right table, non-matching rows from the left table and non-matching rows from the right table. And how do we do that? It's very easy to understand this. You write your query. If you want only the non-matching rows from the left table, you write the query as you do it for left join, and then you will have a where clause. Okay, let's see how to do that. Now if you look at these two tables here, it's the same employees and departments table we have been working with in part 12 of this video series. So if you look at this employees table, James and Russell records have got department ID as null. Okay, so this is our left table and this is our right table. Now I want only James and Russell's records, which means the non-matching rows in the left table. Okay, so how do we do that? Let's write a query for that. So when you write your query, the output should be like this: name, gender, salary, department name. For James and Russell, there is no matching row in the departments table. That's why department name will be null. Okay, but basically I want only those non-matching rows from the left table. So let's see how to write the query for that. So select these columns, whatever you want, from, what's the name of the table? TBL employee, and we want to left join with that table. And which table is that? TBL department table. And obviously join condition on TBL employee dot department ID is equal to departments table TBL department dot ID. So that's our join condition. So if you look at this result, this query now, it's a left join query. Now if we execute this query, we get all the 10 rows from the left table. Okay, the matching rows plus the non-matching rows. So that's what is the inner join query. Left join query. Select whatever columns we want from employee, left join, department on the join condition. So we get the matching rows as well as the non-matching rows. But what's our target. Our target is basically to retrieve only the non-matching rows from the left table, which means we want only James and Russell's records, which means we have to filter out all these 8 rows. Okay, so obviously if we have to filter, we will use the where clause. Okay, and there are 2 ways to achieve this. One is, look at this, you can simply say, okay, I want all these rows, but I want to filter out, okay, where employee table, I basically want only the rows which has got department ID as null. So if you look at this, who has got department ID as null? James and Russell in the employees table. So what you can basically do here is you can say TBL employee dot department ID is null. So the moment you do that, what's going to happen when we press F5, we get all these rows, all this only the non-matching rows from the left table. Another way to do it is, okay, if you look at the presentation, another way is to do it is department.id is null. So department table dot id is null. So when we execute this query, we get the same result, and it's pretty simple to understand what you're saying. Okay, when you say, okay, I want to do a left join, what do we get? We get everything, the matching rows plus the non-matching rows from the left table. Okay, so but we want to filter out James and Russell's record. So as part of that, what is the condition we are using? We are saying department.id is null. So basically for all these records, department ID is not null, hence they will be filtered out. Only these 2 records has got department ID is null. So we don't have a match. As it is, we get all the records from the left table. So these records who has a department ID will be filtered out. So that's how we get only the non-matching rows from the left table. Now let's say I want, if you look at this one, I want only the non-matching rows from the right table. Now if you remember, how do we write a right join? Instead of left join, you just say right join. And when we do this, what do we get? We get, right join will basically give us all the matching rows between the 2 tables plus the non-matching rows from the right table. So there are 8 matching rows between TBL employee and department. So we get those 8 rows plus 1 additional record. This other department record does not have, no employee is assigned that department. Okay, so this is the non-matching row in the right table. Okay, so we get this row as well as the matching rows between these 2 tables, these 8 if we are using a right join. But what is our intention? Our intention is basically to retrieve only the non-matching rows from the right table, which means I just want this other department row. Okay, so how do we do that? All you need to do is, look at this, we basically want to check, okay, wherever the employee.department ID is null. Okay, so basically if you look at this right join here, what is it doing? It's giving you all the matching rows plus the non-matching rows from the right table. Okay, now when you say where employee.department ID is null, for all of these department ID is not null. So obviously these rows will be filtered out, which means these matching rows will also be filtered out, and you only be left with this other department row. So when I say TBL employee dot department ID is null, we only get that other department. So we only get the non-matching rows from the right table. Okay, now let's say I want the non-matching rows from the left table plus the non-matching rows from the right table. By now you would have already guessed what to do. Okay, you will just use an or condition. Okay, so in the where clause we'll say tbl.employee.department ID is null, or tbl.department.id is null. So what's going to happen, we are going to get only the non-matching rows. We are saying, okay, I mean, look at this. When I run this query, I am not getting the non-matching rows from the left table. Why? Because you are using a right join. So you will have to use a full join there. So what does full join give you? Full join will give us all the matching rows between both the tables plus the non-matching rows from the left table plus the non-matching rows from the right table. So if we execute the query until here, we end up getting 11 rows. Okay, 8 matching rows, 2 non-matching rows from the left table, and 1 non-matching row from the right table. But our intention is to filter out these matching rows, these 8 matching rows. We only want the non-matching rows from the left table and the non-matching row from the right table. So in order to do that, we are using this where clause. So when we execute this now, we should only get the non-matching rows from the left table as well as from the right table. So we get these 3 rows. Alright, and one important thing to keep in mind is never ever use, equal to when comparing null value. You cannot say, tbl employee.department ID is equal to null. And along the same lines here, you cannot use equal to operator to compare nulls in SQL Server. You always have to use is keyword. Welcome to Pragim Technologies. I'm Venkat. This is part 14 of SQL Server. In this session, we'll talk about self-join, which is nothing but joining a table with itself. We'll also talk about self-join classification. Most of the people think self-join is a different type of join altogether, which is not true. Self-join can be classified as inner, outer, or cross-join depending on how you write the self-join. Before continuing with this session, I strongly recommend watching parts 12 and 13 of this video series. Now, in parts 12 and 13, we have already seen how to join 2 different tables. Specifically, we have been working with TBL employees and TBL departments tables. But have you ever thought of a need to join a table with itself? If you look at the table here that we have, it has got 3 columns: employee ID, name, and manager ID. Now, let's say I want you to write a query which gives me an output like this. I want the employee name as well as his manager's name. Okay, now if you look at the table on the left hand side, if you look at Mike's manager ID is 3, and you take this 3 and look up in the employee ID column. Okay, 3 is Todd, so Mike's manager is Todd. And along the same lines, if you look at Rob, his manager ID is 1, and you take this 1 and look up in the employee ID column. 1 is Mike. Okay, so Rob's manager is Mike, and we get that output here. So if you look at the situation here, we are using this manager ID column and looking up in the employee ID column within the same table, which means we are referencing the same table. Okay, so here if we want this kind of an output like employee name and manager's name, there is a need to join this employee table with itself. In parts 12 and 13, we have joined TBL employees and TBL department tables. But then in TBL employee table, I had department ID column, which I have used to look up the ID column in TBL departments table, which is another table. But here I'm using this manager ID column to look up employee ID column in the same table. So there is a need to reference the same table, to join with the same table, and that's nothing but a self-join. Now you might be wondering, how can we join the same table with itself? Okay, so if you look at this here, this query right here, we have done exactly the same thing. Okay, select. First of all, we'll talk about these columns just in a bit. Okay, so if you look at the output, we want the employee name and the manager name. So select employee name, manager name. We'll come to those bits in the column list in the select clause in a bit. If you look at the from clause, we are saying TBL employee, and we are giving it a table alias E, and we are saying, okay, join this table, left join. We are doing a left join with TBL employee again. So if you look at this, forget about the type of join here. It can be inner join, left join, whatever. Okay, so select whatever columns you want from TBL employee, give it an alias E, join with the same table TBL employee, and give it another alias M, E for employee, M for manager. So you can assume now we have two instances of this table, two copies of this table rather, employee table and then another table like manager table. Okay, but both of the structures will be identical. You're basically referencing the same table. And then what you're doing is in employee table, take the manager ID column. Okay, in the employee table, take the manager ID column and look up the employee ID in the manager table, which is nothing but another copy of the same table. Okay, and then from the employees table, which is nothing but E, I want the name, which is nothing but the employee name. So I'm giving it an alias as employee. And from the managers table, I'm getting the name, which is nothing but the manager name. Okay, so that's how we get this output. If you look at the join here, we are joining with the same table. So this is nothing but a self join. So let's write this in SQL Server Management Studio. So we'll come to the column list in a bit. Okay, select from which table? From TBL employee. Let's give it an alias E. Left join with the same table TBL employee, but then I'm going to call this M for manager. So this is an employee table, this is the manager table. And how do we want to join that? Okay, in the employees table, I want to take the manager ID column and look that up in the manager table in the employee ID column. So look up employee ID column in manager table using the manager ID column in employee table. You are treating the same table as two different tables now, which means you are actually joining the same table with itself. So what columns do you want now? From the employee table, if I pick up the name, it will be an employee name. So give it a meaningful name. So as employee, give it an alias. And similarly, from manager table, I want the name, but this is going to be the manager name. So manager. So that's it. So when we execute this query, we get the output as we expect. Okay. Now look at this. We are using a left join here, and if you remember from part 12 and 13 of this video series, left join will give you all the matching rows between these two tables plus non-matching rows from the left table. Okay, but if it's an inner join, it will only give the matching rows between the two tables, which means, look at this, when we were using left join, we were getting Todd's record as well. But the moment I change it to inner join, okay, see, if you look at the output right now, we've got 5 rows, including the Todd's record. Now when I execute this one, look at what's going to happen. I only get 4 rows. What happens to Todd record? It's not retrieved anymore. Why? Because if you look at Todd's record, the manager ID does not match with any of the employee IDs. There is no matching record. And if you remember, inner join will only give you the matching records between the two tables. Now you might be wondering, where are two tables here? But remember, in the join, we are joining this table with itself. So we are treating a single table like two tables. We are joining the same table with itself. Okay, so when you are using this column to look up in the employee ID column of the same table, if there are no matching rows and you're doing an inner, the matching rows are not returned if you do an inner self join. So you can call this as an inner self join. Okay, why is it called a self join? Because you're joining the same table with itself and you're doing an inner join, so inner self join. And along the same lines, you can call this query, you're joining. If you look at the first picture here, we are joining TBL employee with manager, but we are doing a left join. So you can call this as left outer self join. Okay, so along the same lines you can do a right outer self join and a full outer self join. So a self join is not a different type of join altogether. It can be classified under any type of join, inner, outer, any of the outer joins, left, right, or full, and cross join as well. We have seen how to write a self, left outer self join, inner self join, but we haven't seen how to write a cross self join. It's pretty much identical. If you remember from part 12 of this video series, a cross join cannot have an on clause. So a cross self join it also shouldn't have the on clause. So if you want to convert this into a cross join, the first thing you have to do, get rid of the on clause and then convert this inner join into cross join. That's about it. Since we are joining the same table with itself, we call it, a self join. But since we are using cross join, it's called as cross self join. Okay. Now remember, in the employee table, we have got 5 rows. And if you remember from the definition of the cross join, when you do a cross join between two tables, you get the Cartesian product, which is nothing but the number of rows in the first table multiplied by the number of rows in the second table. Okay, now here it's the same table. So in the same table, we're joining employees table with itself. In employee table we have got 5 rows, and in the manager table obviously we have another 5 rows. So when we execute this query, we get 5 multiplied by 5, which is 25 rows. So when I press F5, look at that, in the output you should see there are 25 rows. So keep in mind, it's very simple to understand. Joining a table with itself is nothing but a self join. And self join is not a different type of join altogether. Self join can be classified under any type of joins like inner, outer, cross join, depending on how you write your self join query. Now if you look at the output here, when we do a left join, on employee.manager_id is equal to manager.employee ID. Look at this. When we execute this query, we get Todd's record. Todd doesn't have a manager, so the manager name is null. Now instead of showing null, I want to display, since Todd doesn't have a manager, maybe I want to display a text here saying no manager, or I want to say super boss or super manager, whatever. Instead of null, I want to show my own string here. How do I do that? There are several ways you can do it, okay, which we'll be talking about in our next session. Welcome to Pragim Technologies. I am Venkat. This is part 15 of SQL Server. In this session, we'll learn about the different ways that are available to replace null values in SQL Server. Specifically, we'll be looking at isNull function, case statement, and coalesce function. Please watch part 14 of this video series before continuing with this session. Now, I have an employee table which has got 3 columns within it: employee ID, name, and manager ID. Now, if I ask you who is the manager of Rob, you look at manager ID column. Okay, manager ID for Rob is 1, and you look up 1 within the employee ID column. Okay, 1 is Mike, so Rob's manager is Mike. So along the same lines, if you look Todd manager ID value is null, which means Todd doesn't have a manager. And if you remember, in part 14 of this video series, we have written a left outer self join to retrieve employee names along with their manager names. Okay, and this is the output that we have. Since Todd doesn't have a manager ID, his manager name is null, which makes sense. But then in the output, I don't want nulls to be displayed. Instead of nulls, if an employee doesn't have a manager, instead of displaying null value, I want to replace that with no manager. Okay, so instead of an output like this, I want an output like this. Any employee, if he doesn't have a manager, don't display nulls. Replace those null values with this no manager word. Is that possible? Absolutely. We actually have different ways to do that. We can make use of isNull, case statement, and coalesce functions. Let us look at practical examples of using each one of them. Alright, So since we are using this manager ID column and then looking up in the employee ID column, we're kind of doing a self join here. And if you're not sure about what a self join is, please watch part 14 of this video series. Okay, so let's write the left outer self join query. So select, okay, we'll come to the columns list in a bit. First, let's specify the from clause. From, let's say, TBL employee table. We'll call this as E, and I want to do a left join and join with the same table, TBL employee E, but I'm going to alias that with letter M for manager. So this is employee table, this is the manager table. So from the employee table, what do we want? If you look at the output, I want the employee name. So in the from the employee table, I want the employee name, and let's give it a meaningful name, so employee. And from the manager table, I want again the name, but this is going to be manager. Okay, so and we have to specify, so we specified the column list, we specified the employee table, we specified the manager table, we have to specify the join condition. So on E dot in the employee table, take the manager ID and look up in the manager table the employee ID column. And we have seen, I mean, we have discussed about this query in a great detail in part 14 of this video series. So now when you execute this query, we get the output, the employee names with their manager names. But then as we, like how we have it here, Todd doesn't have a manager, so he has null there. So similarly in the output here, null is displayed for Todd. But what's our ultimate aim? Our ultimate aim is basically to replace that null value with no manager word. So how do we do that? The first and the easiest way to do it is basically to use isNull function. Okay, let's see how to use isNull function. Now isNull is such a simple function. Now as the name itself suggests, is null if it is null. Okay, is null. So if you look at this function, the IntelliSense of SQL Server 2008, it shows up the first parameter, it's an expression that you pass in here. If the expression that you're passing in here, if it returns null, then there is a second parameter called replacement value. That parameter will be used. So for example, let's pass a null here for the expression, and replacement value, I'm saying, let's say, no manager. Okay, so when I execute this, what's going to happen? Look at this. Since this function is, we are passing in null as the first parameter, since this is null, it is making use of the replacement value. And look at this, the column doesn't have a name, so let's give it a meaningful name. Let's call this manager, for example. So when I execute that, look at that. Since we are passing null to isNull function, it is making use of the replacement value. On the other hand, let's say instead of saying null, I'm saying Prajim here. Okay, so I'm not passing null now. So when you're not passing null, and if it is not null, then that value will be used. So now instead of saying no manager, it will use that word Prajim. So whatever expression that you pass in here, if it returns null, then this replacement value will be used. If it doesn't return null, then that value itself will be used. So what we have to do is we have to use this isNull function and pass in this m.name into this isNull function. When this expression returns a manager name, it will be used. But on the other hand, for Todd, it returns null. So when it returns null, it uses this no manager. And we will have no manager displayed. So let's see how to do that. You can simply copy the implementation and paste it here. Okay, now we don't want this hard-coded value. Instead, we want to pass m.name. So if this name is null, then use no manager word. Otherwise, use the value returned by m.name. So when we execute this, okay, so Todd has no manager. Pretty simple, very easy to understand. Along the same lines, you can actually use coalesce function as well. So another way to replace null value is to use coalesce function. And if you look up the definition of coalesce function in MSDN books online, it says it is used to replace, it returns the first non-null value. What do we mean by that? Don't worry about that for the time being. We're going to talk about coalesce function in a very great detail in the next session. But for now, understand that the usage of coalesce function is pretty much similar to isNull function, but there is much more to it. Okay, it is basically used to return the first non-null value. Very powerful function. We'll be talking about that piece in the next session. Okay, but what you can do is, coalesce function implementation, using coalesce function is a little similar to isNull. So coalesce, and the way I follow to remember the spelling of this function, that's a little tricky. Coalesce, it's not easy to remember the spelling, but the trick I follow to remember that is I spell it like coal escape e. Okay, that's how I remember that, just in case if you want to use that trick to remember the spelling of the function. Coal, C-O-A-L, escape E. Okay, alright, coalesce, and look at this. When I execute this, I get now prajim. Okay, it's exactly similar to the way we use isNull function. Now on the other hand, if I pass null for that, when I press F5, look at that, I get no manager. But then coalesce is much more powerful than isNull. You can pass in multiple expressions to that, and it returns the first non-null expression value, which we'll be talking about in the next session in a great detail. But for now, just understand coalesce usage is much similar to isNull function. Okay, so if you want to use coalesce, all you have to do is, instead of isNull, just specify coalesce, coal escape E. And when I execute this, obviously Todd, instead of displaying null, we have no manager. And the final way to do it is to use case statement. Okay, now you have this case statement is also very simple. Basically case, the way you use it is case, you specify case keyword, and then you specify an expression here. If that expression case, when you specify your expression, if that expression returns true, then what value you want, else what value you want, and then you end the case statement. So this is the syntax for the case statement. Case, when you specify the expression, this expression returns a true or a false. Okay, if that expression returns true, then use the value here. On the other hand, if it returns false, then use the value in the else part. And this is the end for case statement. So within case, you can have as many expressions as you want. Okay, but here we only have one expression. Okay, so instead of using coalesce here, what you basically can do is you can also use the case statement. So case, when m.name, okay, so when m.name is null, if that is null, then I want to use no manager. Else I want to use m.name itself, whatever m.name. If it is not null, then I want to use the name that is returned by m.name, and then you can end the case expression. That's it. And then you're saying whatever value this case statement returns, that should be the value for the manager column. So this is the alias for that column. So case, when m.name is null, then no manager, else m.name end. Alright, let's execute this and see the output. Okay, look at that. The output is exactly similar. So you can either use case statement, isNull, or coalesce function. We'll be talking about coalesce function in a great detail in the next session. And you can see the implementation right here for 3 of them. Welcome to Pragim Technologies. I am Venkat. This is part 16 of SQL Server. In this session, we'll understand how to use coalesce function with an example. Now, according to the MSDN books online, coalesce function returns the first non-null value. Let's understand what we mean by this. Now, if you look at this employee table here, we've got ID, first name, middle name, and last name columns. And if you look at these employees, some of them have just their first name, some of them have their middle and last name, and some of the employees have just their last name. Now we want to write a query which pulls out the ID and the name of the person, as you can see on the slide. Now when you pull out the name, okay, if the employee has got the first name, you pull that out, okay. But whereas if an employee does not have a first name, and if he has middle and last name, then we want to pull their middle name, okay. And if an employee doesn't have first name and middle name, and if he has only the last name, then we want to pull their last name, okay. But whereas if an employee has both first and middle name, then we just want their first name. Similarly, if he has all of their names, first, middle, and last names, then still we just want their first name. So the priority should first go to their first name. If that's present, pull it out. If not, then middle name. If first and middle name, both of them are not available, only then we pull the last name. Okay, so that's how our output has to be. Alright, so in order to do that, we can use the coalesce function. Now if you look at the query here, to the coalesce function you're passing in, look at this, in the output we want the ID and the name of the person. So obviously in the select list we'll have ID, and then to pull out the name we are using the coalesce function. We are not saying first name, middle name, last name directly. We are passing those column names into this coalesce function. Look at the definition of the coalesce function. It returns the first non-null value. So what's going to happen when you execute this query, this coalesce function will check, okay, in this row, is the first name available? Yes, the first name available. So first name is not null, so it will immediately return Sam. Okay, but whereas when it comes to the second row, it checks, okay, is the first name available? No, it's null. So what happens? It checks the middle name. Okay, is middle name present? Yes. Then what is that? It's not null, it's present, so it's going to return that middle name, which is Todd. Similarly, it comes to the third row, it checks, okay, is first name null? Yes, it is null. So it goes to the middle name. Okay, is middle name null? Yes, it is still null. So it goes to last name. Okay, and then returns Sarah. So we get that. But come here to the fourth row. When it comes here, the first name itself is present. It doesn't even bother to check the middle name. Okay, because coalesce function returns the first non-null value. Okay, so coalesce first name, middle name, last name, and we are giving it an alias name from TBL employee. Okay, let's quickly write this query and see the result in action. So if you look at this, we exactly have the same table here, and we want to select their ID. So select ID, and what else we want? We want the name of the employee. Okay, but we want to use the coalesce function. So coalesce, what do we want? We want to pass into this function first name, the middle name, and last name. So when we pass these three columns, whichever column returns the first non-null value, that value will be used in the output. And we want to give this column an alias. Let's call it name. And from which table are we trying to retrieve this? From the employee table. So TBL employee. So let's execute that. Okay, so if you look at this, we get the output that we expected. Welcome to Pragim Technologies. I am Venkat. This is part 17 of SQL Server. In this session, we'll talk about the purpose of union and union all, the differences between them, and finally, we'll also talk about the differences between joins and unions. Union and union all operators in SQL Server are used to combine the result set of two or more select queries. Let's understand what we mean by this with an example. We have two tables here, TBL India customers and TBL UK customers. and both of these tables have identical columns, ID, name, email in both of the tables. Now let's say if I issue a select query against these two tables, look at this, I am issuing two different select queries, and if I just execute them, look at the result. I get two separate result sets. Okay, in TBL India customers we have got 2 rows, and TBL UK customers we have got 2 rows, and I get these as two separate result sets. Now let's say I want to combine both of the result sets into one result set. How do I do that? Using union or union all. Okay, let's first try to use union all and see what happens. Okay, so select star from TBL India customers table, and then I'm saying union all select star from TBL UK customers, and when I execute this query, look at what's going to happen. It's going to combine the rows from TBL India customers with the rows from TBL UK customers. So when I use this union all, I'm combining the result sets from these two select queries. Okay, now instead of using union all, if I just say union, let's see what's going to happen. Okay, look at this, I got only 3 rows. But let's put it back to union all. We get 4 rows. And if you look at the output here, there is a duplicate record here. Number 2, Sam, and email is s@s.com. So when I use union all, I'm getting all the rows, including the duplicates. But the moment I remove union all, and if I just use union, look at what happens to Sam record. When I execute this, we have got only one Sam record, and look at the output, it is sorted as well. Okay, but whereas when we use union all, it's basically not sorted. It takes all the rows from TBL India customers, combines them with the rows from TBL UK customers and just gives the output. But whereas when you use union, it's doing two things here. It's removing duplicates, and it's also sorting the results. Okay, we'll talk about the differences between union and union all in the next slide. So if you look at the differences between union and union all, union removes duplicate rows, whereas union all doesn't remove them. And another difference is, for union to actually remove the duplicates, it has to perform a distinct sort, and then it has to remove the duplicates. So for this reason, union is a little slower than union all. And this distinct sort operation is actually resource intensive, in the sense it's time consuming. Okay, if you want to see that, you can actually turn on the estimated query execution plan in SQL Server Management Studio. And to do that, you can either press Ctrl L, or you have an icon here which displays an estimated execution plan. So display estimated execution plan. When we click that, what's going to happen is it's going to show us the estimated execution plan. Look at this. In the display here, the distinct sort is actually taking 63% of the time. Okay, but whereas on the other hand, when I use union all and we say display estimated execution plan, there is no distinct sort. Okay, so it just selects the records from TBL India customers and then combines them with the result from TBL UK customers and just displays them. But whereas when we use union, it has to first sort the records and then remove the duplicates, which is a little time consuming. So for this reason, union is a little slower than union all. So these are the two differences between union and union all. Union removes duplicate rows, whereas union all doesn't, and union is a little slower than union all because of the fact that it has to perform that distinct sort to remove duplicates. And this is a common interview question that's asked these days. Okay, so obviously if you use union, we don't get the duplicates, whereas when you use union all, we get the duplicates. Okay, and remember, for union and union all to work, the number, data types, and the order of the columns in the select statement should be the same. Okay, and that should make sense as well. When we actually execute this query, look at this. If we have to combine the results of this select statement with the results of this select statement, obviously the data types and the number of columns has to be same. Okay, on the other hand, if you just say here I want ID and name, and if you say here I want all the three columns, ID, name and email. Okay, now if I try to execute this, look at this. Looking at itself, you can say, okay, first select statement is giving 2 columns, whereas this one is giving 3 columns. How can we combine them? We can't do that. So obviously when we try to execute that, we get an error. All queries combined using a union must have an equal number of expressions in their target list, which means equal number of columns. Not only that, okay, it's not enough if you just have equal number of columns. They should be in the right order. Instead of, if you say, I want ID as the last column, it doesn't really make sense. Okay, how can you combine ID with email? Okay, you can't do that. So when we execute this, look at this, the conversion fail. Okay, because what's happening, it's trying to convert either this one, name to integer, and it fails. Okay, because it detects this as an integer column and it tries to convert this to integer, and it can't be. The implicit conversion fails and we get the error. So the number of the columns has to be the same, the data types have to be the same, and they have to be in the same order. Okay, now you can do this. Okay, look at this. I'm saying, okay, I want ID. You can say ID and email and then name. Okay, you can do this. When I execute this, look at what's going to happen. Okay, I get the output, but if you look at the output, emails are combined with names, and similarly here names are combined with emails. Okay, so as long as the data types are similar, it tries to combine them. Even if they are different, it tries to do an implicit conversion. If the implicit conversion works, then it selects them and combines them. Okay, but if the implicit conversion fails, that's when we get an error. So remember, the number of columns and their data types have to be similar, and even the order has to be the same. If in your first query you have the first column as integer, in the second query the first column has to be integer. If here it's an n-var-char, this has to be an n-var-char, basically a string 1. A string column. Okay, so their data types and their orders have to match, and you need to have equal number of columns. Otherwise, the union or union all doesn't work. You get an error. And we have already spoken about the differences between union and union all. And sorting the results of a union or union all. Okay, this is interesting, and we know that to sort the results, in SQL we use the order by clause. But let's say I have, let's use star for now. Okay, let's say I'm saying select star from India customers, union select star from UK customers. When we execute this, we get the results. Now let's say I want to sort the results by name. Okay, how do I do that? We use the order by class. So order by maybe name. When we do that, look at this, it's not sorted now, but the moment I execute this query, it sorts the results for us. Okay, now if I use order by on the first query, let's see what is going to happen. Now when I execute this, look at this. It gives us an error stating incorrect syntax near the keyword. And it makes sense. Look at this. How does union all works? It takes the rows from this table, combines them with the rows from this table. Now it doesn't make sense to first take sorted rows and then combine. Your result will again become unsorted. That's why after getting all the results, then sort the results finally using your order by clause. That's why I think order by should be only within the last select statement. For example, I have another table called TBL US customers. So when I say union all select star from TBL US customers, and we execute that, it's going to get all the rows from all the tables and then it's going to sort them. Okay, but on the other hand, if you try to use it on the second select, you still get an error. Okay, so if you want to sort the results of union, use the order by clause on the last select statement, like so. All right, and differences between union and join. We have spoken about joins in the previous sessions in this video series. Okay, now unions and joins are two separate things. Okay, but however, these days people are asking this question: what's the difference between a union and join? Okay, join basically, if you look at this, union combines the result set of two or more select queries into a single result set, which includes all the rows from all the queries in that union. Whereas what a join does is it retrieves data from two or more tables based on the logical relationship between those two tables. So usually tables are related to each other using primary and foreign keys. Okay, so we will take the foreign key and look up its value in the other table and join the columns together in those related tables. Whereas in union, we basically combine the rows. So in short, the difference between a union and a join is that union combine rows from two or more tables, whereas join combines columns from two or more tables. For example, we have seen the examples of union. We have taken rows from TBL USA customers and joined them with TBL UK customer rows. Now we did a horizontal kind of a join. Whereas if you look at basically not join, it's union. Okay, but whereas when you look at a join, for example, we have TBL employees table and TBL departments table. In TBL employees table, we have got department ID column, which we then look up in the departments table, and maybe we retrieve the department name. So from TBL employees table, I get employee name and maybe his age, and then from TBL department table, we get the department name. So in joins, we are combining the columns between two or more tables, whereas in a union, we are combining rows between two or more tables. Welcome to Pragim Technologies. I am Venkat. This is part 18 of SQL Server. In this session, we'll understand what a stored procedure is, a simple stored procedure example, creating a stored procedure with parameters, altering a stored procedure, viewing the text of a stored procedure, and finally we'll see how to drop a stored procedure. A stored procedure is a group of transact SQL statements. If you ever have a situation where you have to write the same query over and over again, you can save that specific query as a stored procedure and call it just by its name. Let's understand what we mean by this with an example. Now I have this table called TBL employee, which has got the ID, name, gender, and department ID columns. Let's say I want name and gender of an employee, so we type in select name comma gender from TBL employee. So every time I want the name and gender of an employee, I have to write this query. Okay, instead of that, what we can actually do is wrap this query inside a stored procedure and call that stored procedure rather than you having to write this query again and again. So how do we create a stored procedure? To create a stored procedure, we use create procedure command. So create procedure, and then you have to give this procedure a name. Okay, so SP, let us say get employees. Okay, since this procedure is getting us the employee name and gender, I'm giving it get employees. And look at this, in the name I have this letters SP. A common naming convention for stored procedures is that we usually prefix that with small letter s and small letter p. Okay, indicating that just by looking at this name you can tell, okay, this is a stored procedure. Alright, so create procedure, procedure name, and then you will use as, begin, and end. Okay, so the definition of your stored procedure goes between this begin and end. Okay, so this is the body of your stored procedure. Okay, now when I execute this command, what's going to happen is a stored procedure with this name gets created in this database, which is nothing but sample that we have selected here. Okay, now if you want to look at the stored procedure that you have just created, you want to make sure whether if this procedure is actually created or not. Okay, go into that database, which is sample, and then you have this folder called programmability. Expand that and you should see a folder called stored procedures. If you expand that, we don't have it currently listed there. Just refresh that and you should see that stored procedure which we have just created, which is sp get employees. Okay, so anytime you want the name and gender of an employee, instead of writing this query again, what you can actually do is execute the stored procedure. Okay, so if you want to execute, you just need the name of the procedure. So what happens when I execute the stored procedure? Okay, to execute the stored procedure, you just highlight that and click execute, and you get the name and gender. You don't have to write that query anymore. Now you might be wondering, it's a very simple query, why don't I write that rather than having to create this procedure and then invoke it? Now this procedure may be simple. In reality, the procedures will be long. There are very stored procedures with over 3,000 of lines, for example. Okay, and not only that, there are several other benefits of using stored procedures, from security to reducing network traffic, etc. We will be talking about the advantages of stored procedures in a very great detail in a later session. Okay, so we use create procedure or create proc statement to create SP. You can either say create procedure or you can just say create proc for shortcut. Okay, to create a stored procedure. We'll talk about the naming convention of the stored procedures in just a bit. Okay, and to execute the stored procedure, we have seen how to execute that stored procedure. You just copy that, the name of the stored procedure, and you click this execute button, and what happens, the SQL statement within that stored procedure gets executed and it returns the name and gender columns. Alright, so that's one way to execute it. Or you can use the exec keyword and then click this, or you can use a full execute keyword and then again press F5. Or you can also graphically execute the stored procedure. Just right click on the stored procedure and select execute stored procedure, and the moment you do that, it shows this window. This procedure doesn't have any parameters, otherwise you will have to supply the values for the parameters. In just a bit we will see how to create a stored procedure that takes parameters. Now when I click OK, it executes that stored procedure. Look at that. Alright, so those are the different ways to execute stored procedure. Now let us look at a simple example of how to create a stored procedure with parameters. Okay, so let's go back to that table, TBL employees. Alright, now what I want to do is I want to create a stored procedure which takes two parameters, maybe gender and the department ID. Okay, for example, if I pass gender as male and department ID as 1 to your stored procedure, it should give me employees only within that gender and within that department. Okay, so your stored procedure needs to have these parameters. Okay, so let's see how to do that. So as usual, to create a stored procedure, we use create procedure command. So create procedure and give your procedure a meaningful name. So sp get employees by gender and department. Okay, so I want the employees by gender and department. Now look at this. Now this procedure, okay, the user who invokes your stored procedure is going to pass the stored procedure the gender and the department ID. So for them to be able to pass the values for gender and department ID, they should be parameters. Just like how functions have parameters in C# or any other programming language, stored procedures can also have parameters. Okay, so one is the gender parameter, and if you look at gender, it's text here. So the data type is going to be nvarchar of maybe 20, and department ID is going to be integer, so department ID integer as begin end. So the definition of your stored procedure goes in between these lines. Okay, so what do we want from the table? We want the name and maybe just the gender and also the department ID. From which table we want it? From TBL employee table. but we don't want all names, genders, and department IDs. We want to filter them with what the user is going to pass in. He's going to pass in the gender and department ID. So we are going to say the gender column here should be equal to whatever the user is passing in at gender, and along the same lines, and department ID, let's bring this to another line, is equal to whatever the user is going to pass in. Okay, so these parameters are like placeholders. When users execute your stored procedure, they're going to pass in values for this gender and department ID, which will be replaced at execution time. Okay, so let's create the stored procedure. So to create that, select the entire stored procedure, click execute button, command completed successfully. Now if you refresh the stored procedures folder, you should see sp get employees by gender and department. Okay, now to execute this stored procedure, I just need the name of the stored procedure. And look at this. This stored procedure now is expecting gender and department ID parameters. Now look at this. If I don't pass the parameters and if I try to execute that stored procedure, see, highlight that and then press execute. What's going to happen? This procedure or function sp get employees by gender and department expects parameter at gender which was not supplied, and that makes sense. It's expecting a gender parameter which is not supplied, so we need to pass in the gender parameter. Since gender is of type nvarchar, I have to use single quotes, so I want the male employees within department ID 1. So department ID is 1. So these are the two parameters that this stored procedure expects, and we need to pass them. So when I press F5 now, look at that, I only get male employees within that department ID 1. Okay, on the other hand, if I want all the male employees in department ID 2, I can do so. Alright, now when you have parameters like this, what you're doing is you're just passing in the parameters. So this male value will be taken into at gender parameter, whereas this number 1 is passed into department ID parameter. Okay, now what happens if I put it the other way around? I am passing 1 first. Okay, so what's going to happen? It will take this 1 into gender, and 1 is an integer, but gender is of type nvarchar, and this 1 will be converted into nvarchar implicitly, no problem. But it comes to the second parameter, male, it tries to take this into department ID parameter, and if you look at the data type of department ID parameter, it is integer. Okay, so it tries to convert this string into integer, and it fails, and it throws an exception. Look at this. If I try to execute this now, I get an exception saying that error converting data type varchar to integer. So it is trying to convert this male string of type nvarchar into integer, and we get that error. Okay, so when you have multiple parameters that a stored procedure is expecting, and if you're passing just values, the values order, the order in which you pass them is important. Okay, the first parameter will be used, the value here, the first argument will be used with the first parameter, and the second argument will be used with the second parameter. Okay, that's why the order is important. But if you use the parameter names like this, let's say I want to pass 1 to at department ID, I can specify the name of the parameter like so, and similarly I can specify the name of the parameter for gender. So when I execute this now, I will have no issues because you are specifying the name of the parameter. Okay, so SQL Server knows, okay, this 1 is meant to be the value for department ID parameter, and male is the value for gender parameter. It's only when you don't specify the names of the parameter, the order in which you pass the parameters is important. All right. And okay, so we have seen how to create a simple stored procedure and how to create a procedure with parameters as well, and we have seen how to execute them as well. Okay, now once you have the stored procedures, let's say I have created two procedures until now, sp get employees and sp get employees by gender and department. Now if I want to view the text of these stored procedures, what are the different ways that are available? One way is to simply right click on that stored procedure, script stored procedure as create to new query editor window. This generates the contents of that stored procedure. Look at this. This is the stored procedure definition that we have created. Create procedure, procedure name as begin end, and then our query. This is one way to look at the definition of a stored procedure. And the other way is to use a system stored procedure. These stored procedures that we have created here are user defined stored procedures. These are not system stored procedures. Now SQL Server has some system stored procedures defined, okay, and we use it for certain tasks. For example, I want to find the text of a stored procedure. How do I do that? I can use a system stored procedure called sp_help text. Okay, so look at this. This is the name of the system stored procedure, sp_help text. Okay, sp help text, and then if I pass in the name of the stored procedure there, sp get employees, and then when I select them together and execute this, look at this, I get the text of my stored procedure. You can then copy that, paste it here, and see how does the implementation of the stored procedure looks like. Okay, so to view the definition of a stored procedure, you can either right click on that script stored procedure as create to new query editor window, or you can use the system stored procedure sp_help text followed by the name of the stored procedure, which gives you the text of the stored procedure. Okay, now in this slide, if you look at this, whenever we name user defined stored procedure, Microsoft recommends not to use sp_ prefix for user defined stored procedures, because the reason is system stored procedures has that prefix. Okay, now if you happen to use sp_prefix for your user defined stored procedures, there are two problems. Number one, there will be an ambiguity between user defined stored procedures and system defined stored procedures. Just by looking at the name, we cannot tell, is this a user defined stored procedure or a system defined stored procedure. Okay, and another problem is with future releases of new SQL Server version, there may be name conflicts. If you create, let's say, sp_get date stored procedure, and in the future release there is a system stored procedure which is similarly named sp_get date, it's going to conflict with the user stored procedure. Okay, so to avoid problems like this, it's always better not to prefix user defined stored procedures with sp_prefix. Alright, so to change the stored procedure, now once we have created a stored procedure, for example, I have the stored procedure sp get employees. After I have created the stored procedure, let's say I want to change its implementation in some way. How do I do that? Let's say at the moment when I execute this sp get employees stored procedure, I'm not getting the names sorted, the names are basically not sorted. I want them to be sorted. So how do I do that? I will use the order by clause. So order by name. Okay, so I'm changing the implementation of this stored procedure. Now if I execute this create procedure once again, look at this, we get an error stating that there is already an object named sp_get_employees. Why? We already have that and we are trying to create that again with the same name. So obviously we get that error. Our intention here is to change the definition of that stored procedure, not to create another stored procedure. So if you want to change the definition of the stored procedure, then you say alter procedure, and I press F5, the stored procedure gets changed. Now if we execute that, we should have the names sorted. Okay, so we use alter procedure statement to change the definition of a stored procedure, and to delete the stored procedure we use drop procedure name. Just like if you want to drop a table, you will use drop table name. Okay, so similarly to drop a procedure, you will say drop procedure and procedure name. For example, I want to drop or delete sp get employees. I just pass it there, I press F5, and then if I refresh the stored procedures folder, it's gone now, it's deleted. Or what you can do alternatively, right click on that and select delete. Okay, now it's also possible to encrypt the text of the stored procedure, and it's very simple to do. For example, I have this stored procedure now, sp get employees by gender and department. Look at this. Now this is not encrypted at the moment, so when I use sp underscore help text and when I press F5, I am able to get the text of that stored procedure. So that's how the stored procedure is implemented. Now if I want to encrypt the contents, the text of the stored procedure, I can do that. How do I do that? All you have to do is to use this switch, this option with encryption. Okay, and we want to alter that, so I will say alter. Now when I press F5, look at this, command completed successfully, and now the moment I refresh this folder, look at this, we get a little lock symbol there indicating that this stored procedure is now encrypted. Okay, now if somebody tries to get the text of the encrypted stored procedure, we get a message saying that the text for the object is encrypted and we cannot retrieve the text of that. Okay, and you get the same kind of message when you kind of use script stored procedure as create to new query editor window. Okay, we get this error box. If you look at here, it says the text is encrypted. So once a stored procedure is encrypted, you cannot view the text of that stored procedure. But however, if you want to delete the stored procedure, you can go ahead and delete it. Just right click and select delete. It gets deleted, but you cannot view the contents of a stored procedure that is encrypted. Welcome to Pragim Technologies. I am Venkat. This is part 19 of SQL Server. In this session, we will learn creating and executing stored procedures with output parameters and learn about some of the useful system stored procedures. Now, before continuing with this session, I strongly recommend to watch part 18 of this video series. In part 18 of this video series, we have seen how to create stored procedures with input parameters. In this session, we will see how to create a stored procedure with output parameter. To create a stored procedure with output parameter, we use the keywords out or output. If you look at the stored procedure that we have here, sp get employee count by gender, okay, this procedure has got two parameters, at gender and at employee count. And if you look at the differences between these two parameters, at employee count has got output keyword, whereas at gender doesn't have it. So this output keyword indicates that this at employee count is an output parameter and at gender is an input parameter by default because it doesn't have the output keyword. Okay, and if you look at the procedure definition itself, all we are doing is we are passing in the gender. For example, if you pass in male as the gender, what this query is going to do is it's going to count from employee table how many males are there, and then whatever count you're getting, you're using that count to initialize this output parameter. Okay, now let's see how to actually create the stored procedure. So if you look at this, we have this employee table and we have got some males and females. Now we are about to create a stored procedure which gives us the employee count by gender. And obviously to create a stored procedure, we use create procedure command. So create procedure and then give the stored procedure a meaningful name, sp get employee count by gender. Okay, we want to get the employee count by gender, and this procedure, obviously if you want the total count of employees by gender, at the minimum you have to pass the gender information, like do you want the male employee count or female employee count. So at gender, and this is going to be of type envarchar. Let's say 20 is the size, and then we are going to have another parameter called employee count. Okay, and this is going to be of type integer, and I want this to be of type output parameter. as begin end. So what do we want to do? Now we want to select the total number of employees, for the past in gender, and to do that we will say select. Now if you look at this, select count of star, for example, from TBL employee. This will give us the total number of employees in the table, but we don't want total number of employees. We want the total number of male or female employees depending on what gets passed into the stored procedure. So where gender is equal to, now if I say gender is equal to male, then it will give us the total number of male employees, which is 7. But we don't want to be hard coding the gender like this. Instead, we want to be using the parameter which the user is going to pass when he invokes the stored procedure. Okay, now when we execute this, look at this, we get that count and we are selecting it directly, and we get the result set, but we don't want to do that. Instead, we want to initialize this output parameter. So that's why we will say select at employee count is equal to, so what's going to happen, whatever we get, whatever this count function returns, instead of selecting it as a result set, we are passing it to the output variable, so the output variable gets output parameter gets initialized. Okay, and instead of saying star, it's always good to use the column name there. So let's use ID. So that's it. So let's create the stored procedure. So we have successfully created a stored procedure with an output parameter. All right, now to execute the stored procedure with output parameter, now we have created the stored procedure, we want to execute that. Okay, now usually we have seen how to execute a stored procedure with input parameters in the previous session. Okay, to execute a stored procedure with output parameter, it's slightly different. Okay, now you know that this stored procedure is accepting two parameters. One is the gender parameter and the other one is the employee count. Gender is an input parameter, employee count is an output parameter. Okay, now obviously input parameter means you have to pass something to the stored procedure, whereas output parameter will return something back to you. Okay, now when a stored procedure returns something back to you, you want to hold it somewhere, obviously in a variable. That's why you first create a variable to receive the value. Okay, so I'm creating a variable called at employee total, and notice the data type of this variable should match the data type of your output parameter. Why? Because essentially we get a value of this data type back. So we want a variable basically to hold the value that is going to come out of the stored procedure. So that's why we are creating a variable of integer data type. Okay, and then when we actually execute the stored procedure, look at this, we are executing the stored procedure here. We pass the value for gender, which is nothing but the male, and then what is this query going to do? It's going to count the number of males, and then it's going to initialize this output parameter. Okay, so we are passing in a variable which is going to receive that count. In this case, at employee total receives the value, and then finally we print that value. So let's see how to execute this. Okay, so obviously to execute this stored procedure, okay, first we need to declare a variable, let's say at total count maybe, of type integer. So the data type of this variable should match the data type of the parameter, the output parameter. Okay, and then what you're doing is you're executing the stored procedure. Which stored procedure is that? SP employee get count by gender. And then when you execute, look at this, when you execute that stored procedure, obviously you have to pass in for which gender do you want to count the number of employees, male or female. You have to pass that input value for that input parameter. But whereas for the output parameter you don't have to pass a value, you will get a value back. So here we want to check the count of male employees, and then we pass this variable to receive the value back. Okay, now when you pass that, you need to specify the output keyword, otherwise it will be null. Okay, so that's why, to indicate to the stored procedure, okay, this at total count is an output parameter, you have to specify here that you can either say out or output, it doesn't really matter. Okay, and then finally what you can do is print the value, or you can pass it to another stored procedure, or do anything you want. Okay, so when we execute this, we should get that value back, which is 7 here. Okay, now look at this. If I don't pass the output keyword there, and if I try to execute that, look at this, it doesn't print anything because this is null. Okay, it doesn't receive the value if you don't specify the output keyword, and when you declare it, if you haven't initialized the set total count to anything, it will basically be null, and you will end up printing null. And to quickly check that, you can check that here. If maybe at total count is null, maybe we want to say print at total count is null. All we are doing is we are checking if it is null or not. Else, if it is not null, we want to print a message saying that it is not null. Print at total count is not null. Now if we execute that, look at this, we didn't specify the out keyword. If we don't specify the out keyword, this variable will not receive the value, and since we haven't initialized this variable anywhere else, it is going to stay null, and if it is null, it will print this line. So let's execute this. So when we execute these lines, look at this, at total count is null. But on the other hand, if you pass in something, if you pass the out keyword, what's going to happen, this variable is going to be initialized with the count of employees of that gender. Okay, so now when I execute this, you should get the message saying that at total count is not null, which means it has got some value. Alright, so keep that in mind whenever you execute a stored procedure with output parameter. For that output parameter, you have to specify the out keyword, otherwise it will not be initialized and it will always stay null. Alright. Okay, so if you don't specify the output keyword when executing the stored procedure, the at employee total variable will be null, and we have just seen that. Okay, now here we are passing, look at this, we are if you look at the stored procedure, the first parameter is gender parameter and the second parameter is the employee count. So we are passing in that order. Okay, so the first value will be used by this parameter, the second one will be used by this parameter. Okay, now if you use the parameter names when you're passing values to the stored procedure, then the order doesn't really matter. For example, look at this, let's say I want to pass my output parameter first. How do I do that? You have to use the parameter names. Okay, let's get rid of this here. Okay, so what's the parameter name? It's at employee count. So that at employee count is equal to this output parameter, and you still should have the out keyword, and then you can say at gender is equal to, I want to pass male. Okay, now look at this, I altered the order in which we are passing the parameters, but since I specified the names of the parameter, the stored procedure knows which value is for which parameter. Okay, so obviously if I execute this now, it should work without any issue. So we get 7. Okay, 7 male employees. Alright, there are some extremely useful system stored procedures which we can use for a variety of purposes. For example, here I have this sp_help procedure. It's a system stored procedure, and in the last session we have learned that any procedure that starts with sp underscore is usually a system stored procedure, and user defined stored procedure shouldn't be having that name. Okay, so if you see this sp_help system stored procedure, this procedure can be used to view the information about the stored procedure, like parameter names, the data types, etc. Okay, let's see this in action. Now if I want to find out more information about the stored procedure that we have just created, I can use sp_help take the stored procedure, paste there, and when we press, select those two, and when I press execute, you should see, okay, name of the stored procedure, and look at this, the type is stored procedure, this is a stored procedure, and when we have created it, the parameters it has got, their data types, etc. Okay, so you can use sp_help, or if you don't want to use that system stored procedure, you can go to programmability, stored procedures folder, refresh, and you should see your stored procedure there, and if you expand that, you should see the parameters that it is expecting. All right. Okay, now this sp_help, you can use that with any database object, for example tables, views, triggers, etc. For example, look at this, when I use this sp_help with this TBL employee, what information do I get? I get all the information about the different columns that are present in this table, their data types, etc. Any indexes this table has got, any constraints this table has got. Basically you get the information about the object. Okay, it could be table, view, stored procedure, trigger, etc. So sp_help work with any database object. And if you don't want to use this system stored procedure, you can graphically look at the information about any database object again, or what you can do is simply highlight that object and press Alt F1. That's a keyboard shortcut, and you get the exact same information again. Okay, so that's about sp_help system stored procedure. And in part 18 of this video series, we have seen how what is the purpose of sp_help text. If you want to view the definition of a stored procedure, we use sp_help text system stored procedure. Okay, similarly, even if it is a stored procedure with output parameters, you can still use sp_help text system stored procedure. Okay, press F5, you should see the text of the system stored procedure. And remember, in part 18 we have seen how to encrypt a stored procedure. If you have encrypted a stored procedure, you cannot view the text of that stored procedure. Okay, and finally this sp_depends, which is really useful. Okay, this stored procedure basically is used to view the dependencies of the stored procedure. For example, if a stored procedure depends on a table, look at this, this stored procedure depends. So this stored procedure, where are we getting the information from? This stored procedure is getting the information from TBL employee table. So this stored procedure depends on this table. Okay, so when I execute this, so we get that information. Okay, this stored procedure is depending on these columns, ID and gender, present in this table TBL employee. Okay, now how is this useful? This is useful because let's say I want to drop TBL employee table. Okay, if I drop, when I say drop, I'm going to delete that table. So if I delete TBL employee table and if I try to execute the stored procedure, what happens? It will throw an error because this stored procedure is using that table, and if that table is not present, obviously we get an error. Okay, so I can quickly check, okay, are there any dependencies? And if there are dependencies, I wouldn't delete this table. Okay, so what happens if I delete it? Instead of deleting it, let's rename it to something. So TBL employee 11, I have just renamed it to that. It's as good as deleting it. And now if we execute the stored procedure, look at what's going to happen. It will throw an error saying invalid object name TBL employee. Okay, so you can quickly check, okay, what are the dependencies. Okay, so since you want to delete this table, you can check that table itself. So you can use that TBL employee table here, and when you press F5, look at this, there is a stored procedure that is referring this TBL employee table. Okay, so if you look at the messages here, in the current database, the specified object, which is nothing but TBL employee, the specified object is referenced by the following, which is nothing but this system stored procedure. So it's saying us this this stored procedure is dependent on this TBL employee table. So deleting this table may affect the stored procedure. Okay, so we'll be cautious when we are about to do that. So sp underscore depends view the dependencies of the stored procedure. This system stored procedure is very useful, especially if you want to check if there are any stored procedures that are referencing a table that you are about to drop. sp underscore depends can also be used with other database objects like tables, etc. Welcome to Pragim Technologies. I am Venkat. This is part 20 of SQL Server. In this session, we'll understand what stored procedure return values are, the difference between stored procedure return values and output parameters, and finally, when to use output parameters over return values. In part 18 of this video series, we have seen the basics of stored procedures, and in part 19, we have seen how to create stored procedures with output parameters. If you haven't watched these two parts, I would strongly encourage you to do so before continuing with this session. Now, let's first understand what return values are. Whenever you execute a stored procedure, it returns an integer status variable. Usually, a 0 indicates success and a non-zero indicates failure. Let's understand what we mean by this practically. Okay, so we are in SQL Server Management Studio, and in the Object Explorer, okay, if you open the programmability folder, you should see stored procedures folder, within which I have got a stored procedure sp get name by id. We have created this stored procedure in the previous session. Okay, now if I want to execute this stored procedure, I can just right click on that and select execute stored procedure. Now if you look at the name of the stored procedure, sp get name by id, okay, we want to get the name of the employee by providing his ID. So if I give, ID of 1, then I should get Sam back. Okay, so let's provide the value for ID, which is 1, and when I click OK, look at this, the stored procedure gets executed. I get Sam's name back, which is the expected result. But you look at this, we have a return value as well, and that's an integer, and it is 0 here. So 0 return value, usually 0 indicates success and a non-zero indicates failure. So from this we have understood that when we execute a stored procedure, we get an integer status variable back. Okay, and if that integer status variable is 0, then the stored procedure executed successfully, and non-zero indicates a failure. Alright, with that, now let's try and understand the difference between these return values and output parameters. In part 19 of this video series, we have seen a lot about output parameters. So in this session, we'll talk about the differences between output parameters and return values. Now if you look at the procedure that I have written here, this procedure is called sp get total count of employees. Okay, so in this table I have got 10 employees, so I want to get the total count of these employees. So we are creating a stored procedure for that, sp get total count of employees, and we have an input parameter at total count. Okay, an output parameter at total count. So this is a stored procedure with this we are creating with this output parameter. And what are we doing? We are initializing that output parameter with the count function. Okay, and let's create that practically. Okay, I want to get the total count of employees. So what we can do, we can create the stored procedure, create procedure sp get total count. Okay, let's call it get total count 1. And obviously to get that total count, to receive that total count, let's use an output parameter at total count, and this is going to be of type integer, and it's going to be output parameter as begin end. Now what we want to do, we want to select the total count of employees and initialize this output parameter with that count. So select at count is equal to count of ID from TBL employee table. Okay, so let's execute this stored procedure. Let's create this stored procedure. So when we execute, the stored procedure got created successfully. So we have created the stored procedure now. Now this is stored procedure with output parameter, and if we want to execute the stored procedure with output parameter, we have to first declare an integer variable and then pass the integer variable to the stored procedure with an output keyword. You have to tell this procedure that this is an output parameter, and then we select the value that is returned back into this output parameter. Okay, so let's do that. Declare, let's call at total and integer. So we want to execute the stored procedure, so which is nothing but sp get total count, and we want to pass this output this variable here and use the keyword out, so that this variable will receive the value. And finally, what we want to do, you can either print it or select it, it's up to you what you want to do. So let's print it here in this case. Okay, so when we execute this, we should get number 10 back. Okay, which is the case. So what we have done now, we have created a stored procedure with an output parameter, and which will receive the total number of employees, and we have executed that stored procedure which will print the total number of employees. Okay, now let's go ahead and do the same thing using return values. Okay, so we are creating this procedure. If you look at this procedure is using the return value. Okay, create procedure sp get total count of employees 2 as begin, and if you look at this, we have a return keyword here now, and there is a bracket, there are pair of brackets here, and within that brackets we are saying select count of ID from employees, meaning we are trying to count all the employees here. Okay, so we get 10 employees, so we are selecting number 10 and we are returning that 10. Okay, so this procedure, what it's doing, it's returning the total count of employees, and this procedure, it does essentially the same but in a different way using output parameters. Okay, so let's create the second procedure. So let's call this sp get total count 2, and we are not going to have an output parameter now. Instead, what we are going to do, we are just going to return the total count. Okay, but you should have a bracket here. Okay, so this pair of brackets ensures this statement gets executed first, and whatever is the output, that is returned back using this return keyword. So let's execute this procedure now. So we have that procedure created. Now if you want to execute that stored procedure, okay, look at what you are doing here. You are creating a variable of type integer, and then when you execute this stored procedure using this execute keyword, it returns a value back. So we are taking that value and initializing this variable, and finally what we are doing, we are selecting it, or you can print it. Okay, so let's execute sp get total count 2. To execute that, obviously we need a variable of type integer. Execute this one, sp get total count 2, and then what we want to do, when this stored procedure returns a value, I want to initialize this variable, and finally print that. So obviously when I execute this, we should get 10. Okay, so now if you look at this, I am able to print the total number of employees in my organization, using output parameters as well as using return values. Okay, now let's look at an example where return status variables cannot be used, but output parameters can be used. Okay, all right, so now let's say I want you to write a stored procedure which gives the name of an employee when I give it an ID. So if I pass ID into the stored procedure, it has to give the name of the employee to me back. Okay, so obviously your ID is an input parameter, whereas name is an output parameter. Okay, and what we are doing, we are initializing this name output parameter with the name of the employee from employee table, where ID is equal to whatever ID we are passing in. Okay, and again, this should be pretty straightforward. We have spoken extensively about output parameters in part 19 of this video series. So if you're new to output parameters, please watch that video first. Okay, so let's create the stored procedure. Sp get name by ID 1. Okay, so create procedure. Let's call this sp get name by ID 1. And this procedure needs to have two parameters. When we pass in ID, we will get the name back. So we need an integer parameter at ID integer, and we also need an output parameter which can receive the name of the employee back. So at name, since name is a string, it's envar char of 20, and this is an output parameter, so we need to use the output keyword as begin. And what we want to do, we want to select at name is equal to name from TBL employee table, where ID is equal to at ID that we are passing in. Okay, so let's execute this stored procedure. Okay, so we got the stored procedure created now. Now let's execute this. To execute this stored procedure, obviously we need a variable to receive the name of the employee. So let's call this at name, and this is going to be of type and varchar of 20. And what we want to do is execute sp get name by ID. Okay, so if you want to execute this stored procedure, you have to pass in ID. So let's say we will pass 1, and we want the name of the person back. We know that we will receive the name into output parameters, so we should have a variable which will receive that. So I have created a variable for that, pass that here, and you have to use the out keyword, otherwise this output parameter will not receive the value. And finally, what we want to do, we want to say maybe name is equal to whatever this variable has. Okay, so let's execute the stored procedure. So when we execute that, name is Sam. Okay, so we are able to achieve, we are able to retrieve the name of an employee by passing in ID. ID is an input parameter, whereas name is an output parameter. So our stored procedure is capable of returning the name of an employee, which is of type and varchar. Let's try to do the same thing using output parameters. So we have executed the stored procedure with output parameter. Now let's create a stored procedure which returns the name of the person given we provide it an ID. Okay, the same kind of a procedure but using return values. Okay, so if you look at this, we are creating procedure, we are having an ID parameter, input parameter, and look at this, what it's doing, it's selecting the name of the employee from TBL employee table where ID is equal to at ID, and that has to be inside this bracket. So whatever this query brings back, that is being returned back. Okay, so let's create that stored procedure. So create procedure sp get name by ID, let's call that 2, and we will have only an input parameter, no output parameter, as begin. Okay, select, instead of using the output parameter, what we will do, we will execute this one. Okay, this query gets evaluated, which selects the name of the employee for the provided ID, and we finally return that back. Okay, so let's create this stored procedure. So we have the stored procedure created, and obviously if you want to execute that, since we are using return values, you create a variable of type and varchar, and you will say, okay, that variable is equal to whatever is the result of the stored procedure. Okay, so let's do that here. Okay, so we declared this variable, and what I want to say is at name is equal to execute that stored procedure. It's not 1, it's going to be 2 because this is the procedure that we want to execute, and let's pass 1 as the ID of the employee, and let's execute this and see what happens. Okay, so look at this. Conversion failed when converting the nvarchar value Sam to data type integer. Now if you remember, at the beginning of this video session, we have spoken that whenever you execute a stored procedure, it returns an integer status variable. Okay, now this return value here, when we execute this, the return value of the stored procedure should always be an integer. Okay, a value of 0 indicates success and non-zero indicates failure. Okay, but what did we do here? We are trying to return an nvarchar type. Though you are able to create this stored procedure successfully, at runtime what's going to happen, ID is equal to 1, we are passing 1 here, so for 1 the name is Sam. Sam is the name of the employee, so it tries to convert Sam into an integer because the return value of a stored procedure is an integer. Okay, you cannot convert Sam word into an integer and it fails, and that's why we get this error. So keep in mind, return values, you can use return values only to return an integer. Okay, and that too only one value. Let us say I have a scenario where I want to return the name and gender of an employee. Can I do that with return values? No, you cannot. First of all, they are string data types, so you cannot do that even if they are integers. Let's say, for example, I want to return maybe the pin code and the age of a person, both of them, let's say they are integers. Can I do that with return values? You cannot, because a return value is only one value. Okay, but can I do the same thing with output parameters? Absolutely. You can return any number of values with output parameters and any data type, whereas return values has to be integer and you can only return one value. Okay, so those are the differences between. So if you look at the differences between return values and output parameters, return status value only integer data type, whereas output parameters can be any data type, because you have the flexibility of specifying the the data type for output parameters. Look at this, when you create an output parameter, you specify the data type, but you don't have that flexibility with return values. So they are always integers, whereas output parameters any data type, return values only one value, they can return only one value, but output parameters you can return any number of values. And usually, in general, at least I use return status value to convey success or failure of a stored procedure, especially when we are dealing with nested stored procedures. Okay, and if you really want to return values like name, count, age, etc., we should be using output parameters, not return status variables values. Welcome to Prajim Technologies. I am Venkat. This is part 21 of SQL Server. In this session, we'll understand the advantages of using stored procedures over ad hoc or inline SQL. Now, before continuing with this session, I strongly recommend to watch part 18 of this video series, where we have covered the basics of stored procedures. The greatest benefit of using stored procedures is that they are capable of reusing an execution plan. Okay, let's understand what we mean by an execution plan. Okay, first of all, when we issue a query to a SQL server, three things happen. First, it checks the syntax of that query. Second, it compiles that query. Third, it generates an execution plan. Okay, what do we mean by an execution plan? An execution plan is nothing but for the query to retrieve the data, what is the best possible way available? Okay, now this depends on the indexes that are available in SQL Server to help that query. So based on all these factors, it's going to generate an execution plan, and then it executes the query. So next time when you issue the query, since that execution plan is already generated, it will be cached by SQL Server. So next time when you run the same query, what's going to happen? It's going to reuse that execution plan. Okay, so basically, if it is stored procedures, stored procedures have been doing this from a long time. Okay, they are capable of retaining the execution plan, caching that execution plan, and reusing that. Okay, now even with ad hoc queries these days, they are able to reuse the execution plan. Okay, with the new versions of SQL Server that we have. But the problem is, even a slight change in the query, if it's an ad hoc query, so even a slight change in the query can prevent the execution plan from being reused. Let's understand what we mean by that. I have this table called TBL employee, which is very simple. It has got three columns: name, ID, name, and gender. And if you look at the query here, it select name from TBL employee where ID is equal to 1. Now when I execute this query, what's going to happen? First time when we issue this query, the syntax is checked, it is compiled, and execution plan is generated. And then it executes that query, returns the data back, which is very good. Now when I execute this again, the query is the same thing. Even ad hoc queries these days, they can reuse the execution plan. So it reuses that execution plan and it will be quick. But on the other hand, if I change the parameter, okay, I'm saying in the initial query ID is equal to 1. Now if I pass ID is equal to 2, it is not going to reuse the execution plan. It's going to generate a new plan for this. Okay, but whereas when it comes to stored procedures, look at this. I have the stored procedure. Now to the stored procedure, what the stored procedure basically does is it retrieves the name of an employee, for a given ID. So this stored procedure has a parameter called @id. So when you pass that parameter, it gives the name of that employee. Okay, now if you're new to stored procedures, I strongly recommend to watch part 18 of this video series, where we have covered the basics of stored procedures. Okay, so now when I execute this one, look at this. The parameter that I'm passing is 1. So basically the same thing happens. Okay, the syntax, basically the procedure is compiled and then execution plan is generated, etc., etc. And then when I execute this again, the execution plan is reused. Okay, now even if I execute this, even if I change the parameter to 2, in case of stored procedures, the same plan will be reused. But that's not the case with ad hoc SQL queries. Okay, so in your interview, just in case if you're attending an interview and if somebody asks you, will stored procedures can't ad hoc queries reuse execution plan? They can, but even a slightest change in the query, maybe change in parameter values if it is not a parameterized query, or even a space in the query. If for example, if you look at this query, initially when I execute this, the plan gets created, I execute again, the plan will be reused. But even if I have a simple space here like this, and if I execute the same query again now, it doesn't reuse the execution plan. It's going to generate a new execution plan. So a simple change, space or change in parameter values, can result in a new execution plan being created. Okay, but that's not the case with stored procedures. Stored procedures can reuse the execution plan. Alright, another benefit from a performance standpoint that stored procedures has is they can reduce network traffic. Now, how can they reduce network traffic? Let's understand that. A stored procedure usually is something like this. We create the procedure, there is the body for the stored procedure, and within the body of the stored procedure, in reality, stored procedures are, or they've got enough number of lines. Maybe I have seen stored procedures even with 3,000 lines of code within them, lots and lots of logic happening within them. Okay, now when we have such kind of a stored procedure and we want to execute that stored procedure, all you have to do is from the client application, it could be a .NET application, Java application, or simply a SQL Server Management Studio. So from the SQL Server Management Studio, you just need to specify the name of the procedure, this execute keyword, the name of the procedure, and the parameter values, and then you execute that. Okay, so over the network, what gets transmitted? Just this 3 words. Okay, but if this stored procedure, if you don't have a stored procedure, if it is just ad hoc SQL that you want to send from the client tools, then you have to send all those 3,000 lines of code, which is definitely going to have a impact on network traffic. Okay, so stored procedure, since the stored procedure resides on SQL Server itself, all you have to tell the stored procedure to do is give the name of the stored procedure and the parameters and tell it to execute it. That's it. But if it is not a stored procedure, then you will have to pass all those ad hoc SQL statements from the client tool to the SQL Server, which will definitely increase the network traffic. So that's another benefit. So from a performance standpoint, these are the 2 advantages: execution plan reuse and network traffic reduction. Okay, and another advantage of using stored procedures is code reusability and better maintainability. Now if it's a stored procedure, that resides on the server, now several applications can reuse that stored procedure. If there are multiple applications which want a similar kind of data, they can just call that stored procedure. Okay, now what is the advantage of doing so? The advantage of doing so is that tomorrow, for some reason, if there is a bug in that stored procedure or the logic of the stored procedure has to be changed, you only have one place to change it, irrespective of that being used by multiple applications. So maintainability also becomes much easier. Reusability definitely promotes maintainability. So stored procedures does that. Whereas if it is an inline SQL, What's the problem? If it's an inline SQL, then every application has to issue those SQL statements. They prepare that SQL and then issue those SQL statements from the application. So you have these copies of SQL statements spread across all the applications where you want to reuse that. And tomorrow, if there has to be a change in the logic, you will have to change it across all those applications, which makes maintenance a nightmare. Okay, so definitely stored procedures promote reusability and better maintainability. And from a security standpoint, okay, they provide better security as well. Okay, and they provide security by two means. Let's understand, both of them. In terms of finer grained control, okay, so what do we mean by that? Let's say a user needs data from a specific table. Okay, now if a user needs, let's say I have IT department, HR department, payroll department, and one of the managers or employee needs IT department data. Okay, now if that table has got all these departments data, IT, payroll, HR, and if I grant him access to the entire table, what's going to happen is going to see everybody's records, and we don't want that. Okay, so in those cases, what you can do, you can actually create a stored procedure and grant him access to execute that stored procedure without actually granting access to the underlying table itself. So this allows us to have finer grained control over what data he can see. Okay, so stored procedures can provide security in that angle. Not only stored procedures, we can also use views for that purpose. Okay, but stored procedures is another way. And another way, how stored procedures provide security is they avoid SQL injection attack. Now, most of the people who are new to application development, they dynamically build SQL statements in the application and then issue those to the SQL Server database. Now what's going to happen is in the user interface elements, people can type in SQL and inject that to the dynamically built up SQL code. Now if you don't know how to do that, I have already recorded a video on what is SQL injection attack, how we can actually inject SQL, and how to prevent it using stored procedures. I have a video recorded already on this. Please watch this video. Okay, so these are the greatest benefits of using stored procedures. Okay, from a performance standpoint, they can reuse execution plan and reduce network traffic, and code reusability and better maintainability. And from a security standpoint, you can have finer grained control by granting access only to the stored procedure and not to the underlying tables. And they can also simply avoid SQL injection attack. I mean, not only stored procedures, even if it's an ad hoc query, if they are parameterized queries, they still can avoid SQL injection attack.